পীযূষ, আমি কি পরে জয়েন করব না?
ম্যাডাম কিছু বলেছেন আমাকে, সুদীপ্তা ম্যাডাম?
হ্যাঁ,
স্যার আপনি মিউট করেন।
বলছে আমি কি পরে জয়েন করব না থাকবো?
আপনি থাকেন ম্যাডাম, থাকেন আপনি, হবে।
Good morning to all. Actually, we are waiting for our president, sir. Soon he will come. We will start the program. So hope he will come soon, and we can start the program in time. Though we are lagging behind, but I am hoping that he will join within a short span of time, and then we can start the program. As soon as he will join, we will start the program. Is that?
গুড মর্নিং বিক্রম।
Good morning, all.
Good morning, Sudipta.
Good morning.
Good morning, Babu. Aula. Good morning,
Good morning. Good morning.
Madam. Dr. Shoma Bonik. Good morning.
Good morning.
রঘু কোন সময় আরম্ভ হইব?
ওই তো এখন মানে আমরা প্রেসিডেন্ট স্যারের লাগি একটু অপেক্ষা করি আর।
আচ্ছা ঠিক আছে, কোনো অসুবিধা নেই।
এমনিতে তো সবকিছু ওকে, মানে ওই প্রেসিডেন্ট স্যার যদি ওকে মানে জয়েন করবা।
আচ্ছা আচ্ছা,
আমার তো আপনাদের কারোর সঙ্গে আলাপ নাই।
হ্যাঁ,
লকডাউন উঠেন না বুঝছো, আর আমি শিলচরাইয়া দেখা করার লাগে খুব ইচ্ছা। হ্যাঁ, আইতে পারি না।
হইব সব শেষ হোক, আমরা পরে এখন মূলত বুঝতে। আচ্ছা রঘু,
হ্যাঁ,
আমি পরিচয় করাই দেই। সুদীপ্তা হইলো আমার ব্যাচমেট আর কি কলেজে।
আচ্ছা
আমরা 2 বছর একসঙ্গে পড়ছি হাই সেকেন্ডারি। বর্তমানে তো তাই বিশ্বভারতীতে আছে।
নমস্কার।
রাহুল দা, সুদীপ্তা, রাহুল দা আমাদের 1 বছরের সিনিয়র।
রাহুলদার সাথে তো আমার খুব ভালো সম্পর্ক।
না, আমি সুদীপ্তারে কইরাম পার্টিকুলারলি।
ও আচ্ছা,
তো
সুদীপ্তার সঙ্গে প্রথম দেখা।
আমি আসলে বিএসসি এখানে করছি না, তো আমি এইচএস এর পরেই বাইরে গেছি কাজে, এইজন্য
অ্যাকচুয়ালি ম্যাডাম কি জানেন সুদীপ্তা ম্যাডাম
আমরা পাড়া তো।
আচ্ছা
আমরা পাড়া তাইলে শ্মশান রোডের, তারা বাড়ি আছে শ্মশান রোডে।
এই সেটেলমেন্ট
সেটেলমেন্টে
এখন বুঝে সেটেলড কলকাতাতে।
আমি জানি আমার মুখে হয়তো চিনবা আপনারা, মঞ্জু সেন রবীন্দ্র সদন কলেজে পড়াই।
কমেন্টের সাথে চলে যাও, তুই পাইছত না বুঝে, রবিও পাইছত না।
এখন ম্যাডাম কি মানে ওয়েস্ট বেঙ্গলে সেটেল নাকি?
এখন শান্তিনিকেতনে সেটেল।
পৌলমী
তারপর-
পালিত কথা কইছে,
হ্যাঁ
হ্যাঁ
পৌলমী পালিতছে, ওই যে আমরা অজিত পালিতর যে মেয়ে যে
হ্যাঁ
তাই
পৌলমী।
অপোজিটের ইয়ে পাইতে বোধ টাকা না?
পৌলমী, হ্যাঁ আমরা একই কমপ্লেক্সে।
হ্যাঁ, আমরা কইছে কালকে,
আচ্ছা
গতকালকে একটা ইয়ে আছে আমরা ডিসকাশন, তখন কইলো কি জায়গা ভালো যে শান্তিনিকেতন আইলে মোটামুটি সব একসঙ্গে পাওয়া যাবে।
একটা প্ল্যান করিয়া একবার আমরা সবাই যাই একবার শান্তিনিকেতন।
মোস্ট ওয়েলকাম, ভালো লাগবে।
রঘু কোন
হ্যাঁ
করো তো
চলো
নতুন করো নি?
শান্তিনিকেতন। বাহ,
হ্যাঁ
তোর নতুন করো নি তুই?
ওয়ে এও গেছে তো ডিসেম্বরের 2 তারিখ থেকে 19।
আজান বলিস না। তাও না
ও কো হ্যালো।
শ্রীপর্ণার সঙ্গে দেখা হয়েছিল কয়েকদিন আগে। শ্রীপর্ণা যে
হ্যাঁ
তোমার বোন যে শ্রীপর্ণা,
বুঝছি বুঝছি, হ্যাঁ বাহ,
তো শ্রীপর্ণার বাড়ির ঠিক পিছন দিকে আমি ঘর তুললাম। তো
হয়েছে কতটুকু তুললে, কতটুকু হয়েছে?
আমরা তো জাস্ট খালি পাইলিং করাইছি, এরপরে তো লকডাউন লাগি গেল। লকডাউনের মধ্যে করছি কিছু কাজ, এখন তো কাজ বন্ধ, কারণ করোনার লগে আইতে চায় না কেউ। আবার শুরু করবো সেপ্টেম্বর থেকে, তো তাই আমার প্রতিবেশী এখন।
করোনা এখন তো,
হ্যাঁ, তাই এখন
তারা
আমার
তো
প্রতিবেশী।
প্রতিবেশী প্রচুর করোনা।
আরে ভাই, রাজকলনের অবস্থা-
আশেপাশে
রাজকলনের
তো
অবস্থা খুব খারাপ। রাজকলনের অবস্থা খুবই
করোনা
খারাপ।
প্রচুর রয়েছে।
হ্যাঁ,
তার বাড়ির আশেপাশে সবার করোনা পেশেন্ট।
হ্যাঁ,
যাই হোক, আর কি করবা, সামথিং কিছু করার নেই, সিচুয়েশন এমনই হয়েছে।
হ্যাঁ, situation একদম মানে ইয়ে করে দিয়েছে আমাদের।
আজকে একটা দেখলাম তারা একটা ন্যাশনাল পলিসি অফ এডুকেশন নিয়ে একটা ইয়ে সেমিনার, খুব সম্ভবত
হ্যাঁ, হ্যাঁ।
ন্যাশনাল পলিসি অফ এডুকেশন নিয়ে।
তারা খুব সুন্দর সুন্দর
ওয়ান অফ
সেমিনার
দা
করে।
কোঅর্ডিনেট।
হ্যাঁ, দেখছেন যে কোঅর্ডিনেটর, তারা খুব ভালো ভালো টপিক নিয়ে করে, কারণ তারা ডিপার্টমেন্ট গুলোতে এই টপিক গুলো মানে ন্যাচারাল ইস্যু নিয়ে
দেখে
আলোচনা।
তারা সবাইকে ফিট করতে পারে, মিন্স তারা তোমার সব একাডেমিশিয়ান এক প্ল্যাটফর্মে আনতে পারে। এডুকেশন এমন এক জিনিস, তারা সব প্ল্যাটফর্মের লোকদেরকে ওয়ান প্ল্যাটফর্মে নিয়ে আসতে পারে।
একটা প্লাস পয়েন্ট ওদের।
আপনাদের সবাই অনুমতি দিয়ে শুরু করে দেই, কারণ প্রেসিডেন্ট স্যার বোধহয় একটু সমস্যা ওর। হ্যাঁ স্যার,
হ্যাঁ,
ইনঅগুরাল সেশন লাস্টে প্রেসিডেন্সিয়াল অ্যাড্রেস করবেন।
হবে কোনো
সো
প্রবলেম নেই।
ম্যাডাম আপনি
No problem.
একটু কাইন্ডলি রেডি থাকবেন, কারণ প্রেসিডেন্ট স্যার পরে লেকচার করবেন, আপনি কনভেনারের লেকচারটা মানে দিয়ে দেবেন। হ্যাঁ, তো গুড মর্নিং টু অল। A very good morning to all. Okay, so due to some technical problem, once again I am starting the program. A very good morning to all. A hearty welcome to one and all to the one-day national webinar on recent advances in physics research, being organized jointly by Department of Physics, Government Degree College, Dharmanagar, and Department of Physics, Women's College, Agartala. Respected Patron Madam Monidipa Devborma, Principal, Women College, respected President Sir Sri Gautam Das, Principal in charge, Government Degree College, Dharmanagar, respected invited speakers, Dr. Himadri Shekhar Das, Assistant Professor, Department of Physics, Assam University, Dr. Sudeep Das, Assistant Professor, Department of Physics, Vishwabharati Santiniketan, Dr. Ratan Das, Assistant Professor, Department of Physics, Tripura University, and Dr. Rahul Bhattacharjee, Associate Professor, Department of Physics, Women's College, Agartala. Respected Organizing Secretary, Dr. Sujit Ranjan Das, Assistant Professor, Department of Physics, Government Degree College, Dharmanagar. Respected Convener Madam, Dr. Shuma Vanik, Assistant Professor, Women College, Agartala. Other respected members of Organizing Committee, and most importantly, dear all participants. I welcome one and all to this national seminar webinar. Really, we are spending tough time for a couple of months and nobody doesn't know how long it will be continuing. During this pandemic period, we are not able to meet physically. Seminar, workshops are not possible under this situation. So, otherwise, it's an opportunity to do collaboration work or joint venture and to extend helping hands to each other for joint work. Taking this an opportunity, Government Degree College, Dharmanagar, Department of Physics, and Women College, Agartala, Department of Physics, are jointly organizing such a webinar. This is an open platform where views can be shared, to collaborate each other, and particularly students, young researcher will get opportunity to widen their knowledge in physics research, will grow interest in higher studies, will come to know what are the recent developments in the field of physics and many parts of physics, particularly research from the learned resource persons from our invited speakers. Hope all the participants actively participate in the discussion and take part in active interaction. I wish a grand success of this national webinar. I sincerely thanks all the invited speakers, members of the organizing committee, then the participants who have participated and enriched today's discussions. Hope after these discussions, particularly our students from our college, from Women's College, and from other college, and the young researcher will get benefited. And we could share our views in the open platform, and by this way, we can enrich the physics research in the days coming. Okay, thank all of you once again. Now, I request and invite Dr. Shuma Bonik, convener of this webinar. Please share a few words in this national webinar. Shuma Madam,
Thank you,
please.
sir. Yes. Am I audible?
Yes, ma'am.
A very good morning to you all. So it's an auspicious occasion, a joint venture organized by two degree colleges of Tripura. I think for the first time, Government Degree College Dharmanagar and Women's College Agartala have taken a joint initiative to make an interactive platform where resource persons from different institutions will come under an open umbrella And this type of initiative in this virtual platform has made source for interactions, scope for interactions to academicians, students. And in this occasion, we have 4 speakers, Dr. Himadri Shekhar Dash, Dr. Sudipta Dash, Dr. Ratan Dash, and Dr. Rahul Bhattacharjee. They will be enlightening us on various aspects of research, ongoing research in diverse fields of physics in the upcoming technical session. And a lot of participants have joined us on this virtual platform. They are viewing us on YouTube Live. Hope they will interact actively. They will make this platform an interactive one, and their active participation will make our endeavor a successful one. So hope for your active participation. Be with us till the end and hope for a grand success of this webinar. Thank you. Sir, please unmute yourself.
Raghu sir, please. Yeah.
Very actively, Madam took part in this national seminar. From the front, the Suma Madam and our Sujit sir and Rahul sir taken initiative for making this one-day national webinar a successful one. So once again, I am thankful to her. I am expressing my gratitude to her. Our patron madam of this today's webinar, she is absent, but she has shared a message with us. I'm reading her message, which will be helpful for our students and the young researcher. So I am reading the message of patron madam. So it gives me immense pleasure to share that Department of Physics, Government Degree College Dharmanagar, and Department of Physics, Women's College Agartala are jointly organizing a national webinar on recent advances in physics research. For the first time, it is a very praiseworthy initiative during this pandemic period. In this platform, all the resource persons will be sharing their views on the recent development and new innovations in the field of physics, which will be very interesting and beneficial for all physics enthusiasts. I hope this kind of joint program will be continued in the near future too, which will help the student community. I would like to thank all the members of organizing committee, teachers, students, and other participants for making this program a grand success. So I am thankful to Madam, Patron Madam. She has shared very valuable words with us. So once again, from the organizing committee, we are expressing our gratitude to her, Patron Madam. So our President Sir not joined yet. So after end of this session, the inaugural sessions will be followed by the technical session. And after the technical session, as he is not present yet, so he will be delivering his presidential address. So May I now request Dr. Himadri Shekhar Das, Assistant Professor, Department of Physics, Assam University, for delivering lecture. Would you please, sir, deliver now, or we wait sometimes for him?
Sure. Thank you very much, Raghu sir.
If sir,
First of
you are, just a minute, sir. এদিকে আসো তুমি একটু। হ্যাঁ, আচ্ছা তুমি ইয়ে করো, এটা আমার ইয়েটা কই? ওই তো ইয়েটা তো আমার তো আছে, ঠিক আছে? Okay, sir, Imantri sir, as our president sir has come, so I am
okay,
requesting him to address.
sure.
So Sri Gautam Das, principal in charge, Government Degree College, Dharmanagar, and president of this one-day webinar, I am requesting you to please deliver your presidential address to this one-day webinar. Gautam sir, please.
Thank you, sir. Hello, Raghu sir. Are you hearing me?
I am hearing you.
Thank you.
You are audible, sir.
Thank you. Very good morning to all. We are very happy for receiving such a warm response from you. On behalf of Government Degree College, Dharmanagar, Tripura, I extend a warm and hearty welcome to all the participants, the resource persons, delegates in this national webinar on recent advances in physics research, jointly organized by Physics Department of our college and Physics Department of Women's College, Agartala. To develop world-class citizens to our students through quality education by maintaining the dignity of teaching professions. It is the mission of our institutions. We are in a position to organize these types of national and international webinar as we have a large number of dynamic and energetic faculty members in our college. Our government degree college, Dharmanagar, has completed 3 national and 1 international webinar within last 50 days. And a 7-day workshop will organize in first week of September 2020 in this college. I extended my congratulations to Dr. Raghunandan Das, Assistant Professor, and Dr. Sujit Ranjan Das, Assistant Professor of our Physics Department, for very neatly and promptly organizing this webinar. I take this opportunity to extend my wholehearted gratitude to honorable research persons, Dr. Himadri Shekhar Das, Assistant Professor, Assam University, Silchar, Dr. Sudipta Das, Assistant Professor, Vishwabharati, Shantiniketan, West Bengal, Dr. Ratan Das, Assistant Professor, Tripura University, Agartala, Dr. Rahul Bhattacharjee, Associate Professor, Women's College, Agartala. They share their valuable time with us. I congratulate Principal Madam of Women's College, Agartala, for her unconditional supports to our digital program. She is also the patron of this program. I would like to convener Dr. Shoma Boni Assistant Professor, Women's College, Agartala. Organizing Secretary, Dr. Sujit Ranjan Das. In this pandemic COVID-19, we all are under stress. I think this webinar will give us boost in developing our depth in advanced physics. I am sure this program will enhance the level of information, knowledge to all the participants. I take this opportunity to extend my best wishes for this program. Life is education and education is life. I wish this program to be a grand success. Thank you once again. Namaskar.
Okay. Thanks a lot to President Sir for his presidential address. Very nicely he enlightened us. We have come to know a lot from him. And from the front, he encourages us for organizing such kind of webinar. So once again, thanks a lot. Now may I request Dr. Himadri Shekhar Das, Assistant Professor, Assam University, Department of Physics. So let me first introduce Dr. Das to all the participants, particularly students of our college or women's college and other researchers. Some of the students already know him very well. He came whenever we uh, wanted or whenever we invited him. All times he came and shared his valuable speech, valuable things with us. So let me now introduce Dr. Dash to all the participants. In very brief, as we are running short of time and we would like to complete this program in time schedule, so in very brief, though there are so many things to say about him, but in very brief, I would like to share a very few words to all the participants. Dr. Himadri Shekhar Das, Assistant Professor, Department of Physics, Assam University, Silchar. He was a research fellow in the Department of Energy, Government of India. He was a recipient of Indo-US Science and Technology Forum Fellowship. He had visited many higher educations in India and abroad as USA, Japan, Israel, China, France, Belgium, Netherlands, etc. for research work. He published more than 70 research papers in national and international repute journals. Dr. Dash was honored by ex-President of India, Sri Pranab Mukherjee, in Inspired Teachers at Rashtrapati Bhavan in 2015. He is a life member of IAU, ASI, and PANE. His research interest is includes scattering properties of atomic dust, star formations, comets, etc. So now I humbly request Dr. Himadri Shekhar Das, Assistant Professor, Department of Physics, Assam University, please share your valuable things with us. Please.
So before going to start my talk, at what time I should stop? Because as I can see, already 15 minutes. So
Yes, sir.
my talk is scheduled after 12. So 12:15 is my time, no?
No, sir. Please, you continue and half an hour you will deliver the lecture. After the half an hour, This your lecture will be followed by an interaction session. If necessary, we will cut short this interaction session. So please, you continue your lecture for half an hour.
Sure, I'll try to finish my talk within time. First of all,
If necessary, because I know very valuable words you will be sharing. So if necessary, if it will be required, then you may take 10 minutes or 5 minutes more. But
I can
please try
understand.
to complete
I can
within the.
understand three more speakers are there after my talk, and it is very difficult to listen all the talks for a long time. So I'll try to finish very rapidly. And first of all, I would like to thank Government Degree College Dharmanagar and Women's College Agartala for inviting me in this webinar, because this webinar is specially designed for the students and the scholars who are coming from different corners of the country. Uh, Respected principal of Government Degree College Dharmanagar, then respected principal Women's College, then my friend Dr. Sujit Ranjan Das, who is the organizing secretary, then Dr. Shoma Bonik, she is the convener of this session, and finally Dr. Raghunandan Das, who is a very active member. Whenever you, because I know him for last 25 years, 22 years, and he's a very active person since our college days. We are associated. And before going to start this talk, I would also like to give my best wishes to my colleagues, Dr. Sudipta Das from Vishwa Bharati. She is also my friend. When I was in college, she was my friend. Then Ratan was my junior, Dr. Ratan Das, and Dr. Rahul Bhattacharya was also my 1 year senior. So I also welcome them in this webinar. So now I'll be going to start the session. Before going to start this session, I would like to tell you that the topic which I have chosen, this is basically, it is not that comet has arrived just now, and we are going to start this topic, because this is my research topic, and I have been working in the field of comet for more than 20 years. I joined in 2000 as a PhD research scholar. After that, I started working on comets. So basically, this is my research field, and why we have taken this topic, because nowadays this comet Neowise is actually uh, uh, is very, what to say, that nowadays it is people are observing this comet in the sky. That's why it is a very hot topic. So probably that's why I had chosen this topic. So my topic is the mystery of comets. So the slide is visible. Dr. Raghu, can you see the slides? Can you see the slide?
Yes, I can. But it is just behind you. So yeah, it's nicely now visible.
Yes, now it's visible.
Yeah.
Okay, it is
Nicely
not
now.
an issue, because now you just see whether it is in full screen it is coming or not.
It's coming.
It is coming. Okay, thank you very much. If it is coming, then my job is to present. So comets have fascinated and attracted the people for more than 2000 years, and that's why comets are always, since the civilization starts, comets have attracted the people. In this picture, you can see this is comet Neowise, which was recently been photographed by one of the photographers from NASA. And this is Stonehenge. Those who have idea about the Stonehenge in England, this is one of the great monuments people usually visit. And the photograph of this comet was taken from that place, and this is comet Neowise. So before going to start this topic, I'll just show you a video which actually nicely uh, represents what is actually comet.
मुसाफिर हूँ यारो, ना घर है ना ठिकाना। मुसाफिर हूँ यारो, ना घर है ना ठिकाना। मुझे चलते जाना है, बस चलते जाना।
So, what to say that Comet is a Musafir, and probably you have heard this song, Musafir hu yaro, na ghar hai na ठिकाना, मुझे बस चलते जाना है. So I like this song very much because it is a famous song sung by Kishore Kumar from the movie Parichaya, and in that movie, the song actually represents if you are a visitor, you have to go and go. If you have to move from here to there, and comet is something like that. So if you want to understand what is comets, the basic definition of comet is this is comet Neowise, which was recently being in news. This comet Neowise was you can see two tails of comet Neowise, and comets are basically dusty snowballs which orbit the sun. What they are made up of ice, water, carbon dioxide, ammonia, and methane mixed with dust. These materials came from the time when actually our solar system was formed. So, with these few lines, I have defined what is comet. So, probably in that movie, you have seen that a big rock is coming. That rock is actually made up of ices basically, and water ice is there. So when it approaches towards the sun, sublimation takes place because the sunlight heats up the nucleus of the comets. Then this evaporation starts, and ultimately you can see the long tail of comets. So in this picture, you can see that the one person is observing comet with a telescope, probably in a winter country, and he has thrown a ball, and he's telling that Henry was sure that he had visually confirmed the comets. Really just that is known. So I had given the name Cometoon. What is Cometoon? Basically, Cometoon is actually Comet cartoon, Comet plus cartoon. So I had given the name Cometoon. So I'll also show you some other cartoon. In history, probably in the beginning of my talk, I told you that comet had impact in history. People have observing the comet for last few 100 years. So this was a recording of first comet in 1007 AD, when a wondrous comet actually appeared. And one of the painter has drawn this nice picture. This particular pictures were actually made to public recently. This is the second picture which was taken in the year 1066, and in this picture you can see here one of the comet is there, and people are looking, that's showing this is a comet, and this is the King Harold, and this is there in one of the church in England. I'll tell you about the story of this church. This comet appeared in 1300 AD, and you can see how beautiful the comet was, and it was taken from the Book of Miracles. So this is another comet. It was also a big comet, and it appeared in 1401 AD. So this is the great comet of 1577. Actually, it created a very superstitious among people, and people just started coming out from the home because the comet was.
Himatri sir,
Yes,
just
yes.
interview. Yeah,
Yes, yes.
so some participants are probably having some problems in audio. Please, they are requesting you to speak little louder voice, if it is
Okay,
possible.
can you hear me?
Yeah, I am hearing you, and you are audible also.
Okay. Okay, I'll
Yeah,
try to
some
speak a little
participants may
louder.
have some problem. That is why they are
Okay, sure.
writing some comments.
Sure.
Okay, please.
Okay, so in case any that sound mute is there, then you just inform me.
Okay, sir.
Okay. So this is the Great Comet of 1577. When people were observing this comet, the comet was too long, and it was actually spreaded in the whole sky, and people were having some afraid of this comet. This is one of the nice comet, the six-tail comet. This is very rare because normally comet has two tails, but in this particular comet, and the tails are around six tails are there. So that was also a painting, not the actual picture, because that time the photography was not discovered. This is the Great Comet of 1843, the long tail, and according to the record, we believe that this is the longest tail observed till date. This is an anthropomorphic comet. Those who have idea about anthropology, in anthropology, the human characters, they study the human character phenomena. And in this picture, all the events are related to humans, and the painter, he has nicely portrayed all this in a single picture. Now, these are all our paintings. Now I'll show you the actual picture of the comet. This is comet Halley, which was taken in the year 1986. And this is comet Hyakutake. Probably some of you know that comet Neowise is nowadays visible. Nowadays not, but 1 week before it was visible in the night sky. It was a very bright comet, and one can see that comet with naked eye. And before that, 25 years ago, two comets were very bright enough to see from the night sky. In the year 95-96, the comets were comet Hyakutake and comet Halley. I am showing you comet Halley, and you can see nicely. That time I was in college. I was studying in degree, and that time we had observed this comet from college. This is another comet, comet McNaught. This is comet Levy. This is comet Hale-Bopp, and this was the comet which we observed from one of the observatory in India. It is Ayuka Girawali Observatory, Pune. In 2011, we observed this comet. This is comet Aizong. Comet Aizong was in news in the year 2013 when it visited the comet. When it visited the sun. Now I'll show you comet Neowise photo gallery. You know that probably in recent years, comet Neowise, recent days, Neowise is in news. Every day, new information people are getting about this comet. So this is the first photograph. This was one of the photographs taken by one of the astronomers who are there in the International Space Station. And you can say this is Earth and this is the International Space Station, and he had actually spotted the comet Neowise. This is taken from the space, comet Neowise. This is from one of the amateur astronomers who had taken this comet. And this particular photograph is very nice. Actually, I had taken this photograph from Instagram. And you can see one girl is standing, and from his finger, the light is coming out, which is nothing but the comet. These are the ideas of different photographers who are actually taking. So this is another photograph of comet Neowise. Just look at this picture. And this is another photograph taken from the Seven Magic Mountains by artist in Las Vegas. So these are some of the monuments. People always try to photograph such astronomical moment nearby a historical monument, because this is the history, and that's why they keep it for future references. This was taken from one of the mountain, and you can see two tails of comets are visible. And this is another one. Okay, so I had shown you the different photographs of a comet, but now I'm going to the comet history. Who first observed the comet? The Chinese observation in 240 BC was the first listing of comet in the recorded history. And you know that the Chinese people had the idea about the paintings in a paper. So this is the silk paper they had actually made, and in that they used the vegetable ink, and then they recorded the comet Halley. Probably in the beginning, I had shown you this picture. So this is there in the Bax tapestry in England, one church in England where the comet is appeared. So this is comet Halley, which appeared in 1066 AD. In this particular painting, you can see that this painting is depicting that blood rain is going on. Two comets appeared, two-headed dogs. Then boys are crying. So everywhere some disturbances are going on. So the painter had tried to actually portray this. And in this picture, you can see the tail of a horse is equivalent to the tail of a comet. And this is the picture taken. This is the painting which was drawn by one of the painter. This is comet Hyakutake, which appeared in the year 1997. So what I wanted to tell you that this comet has not only impressed astronomer but also impressed the painter around the world. So this is the cartoon which appeared in 1910 when comet Halley was coming, and there was a news that comet Halley may collide with Earth and Earth will destroy. But in this picture, you can see that sun is laughing. What does it mean? It means that this sun represents the scientists. So that there is no such incident going to happen on Earth. And in this comettoon, you can see that the Greek people were the first to observe the comet systematically. And particularly in this picture, you can see that the two dinosaurs were looking at a shooting star, and they are saying, "Oh, look, a shooting star making." You know that the appearance or disappearance of dinosaurs were related with the collision of an asteroid or comets. So that's why that cartoon were made. And in that particular, this was taken from NASA page, and you can see that even if they see a fly which is looking like a comet, and immediately they surprised. And this is another one. So I have collected this so that you will get some interest. My intention is not to go to the detailed technical things, but to give you a brief idea what is going on. So they are welcoming this comet with a big telescope. So this is the famous comet. This is the famous cartoon character. So this is the famous cartoon character Tom, who actually for the first time, who actually showing you the asteroid alert. Who actually showing you asteroid alert, and people are afraid of this. So here one lady is asking, one lady is asking about is there asteroid going to collide with the Earth? His response is no comment. So normally what we do, we ask, we tell no comment, but here it is no comment. So here a boy has broken the wall, broken the glass, and now he is giving the justification that it is not because of me, but it is because of the many comets which actually collided with the glass. So this cartoon actually appeared in 1999 when the internet was in news, and in London Times newspaper this is actually appeared. So master and dog are watching the live meteor shower. Suddenly there is a call from the home, and they are going inside because they are saying that that live show is showing in the TV. So they're just going inside, and because of that, dog is actually embarrassed because he was observing the live night sky observation. So this has its history. One of our professor, he is no more today. When I had shown this particular cartoon to him, actually when I was preparing a talk, he came to me and suddenly he saw this picture. You know that the orbital period of comet Halley is 76 years. So in this picture, it is showing that when boy was very young when comet Halley came, and after 76 years it came, but when again it came back, the person was no more. So looking at this theme, one of our professor, he was actually actually he was associated with our, and he was pro vice chancellor of the university, Professor Anandu Gotel, and he had written this poem particularly for me. And now onwards, whenever I deliver any talk anywhere, actually I never delete this particular message. So what I want to tell you that people had not only from the science background, people from literature also had shown their interest in this particular topic. Mark Twain, a great American novelist, also written limerick about comet Halley. So this is the comet jokes which actually appeared. So if you ask Mrs. Halley, she will say that actually he used to come daily. Now he comes once every 76 years. And the next thing is, what do you call a story about a comet? A tale. How to flirt with the comet? Tell the comet it has a nice tail. So, comet is also there in this fashion industry. You can see this is a cosmic collection, and in fashion industry also they are using this. And not only in fashion industry, also boys are busy buying the cars. So this is gigantic Ford Helix comet. Now I'm going to the scientific part of the objective. You can see here that a comet is showing in the screen, which is comet Hale-Bopp, and it was actually animated from the. Actually, this is comet Hale-Bopp taken from Hubble Space Observatory, and later it was. The comet actually rotates whenever it approaches towards the sun, and the sublimation of ices took place because of the sun. So, what is the comet? Comets are small celestial bodies, several kilometers in diameter, constituted mainly of water, ice, rock, and the appearance of these comets are associated with disaster, calamities, tragedies, etc. So ancient beliefs. These are the ancient beliefs, but nowadays we believe that comet has nothing to do with all these disasters. Ancient records, already I told you, the paintings of recordings on comet and cliffs. And Chinese for the first time observed this comet in 250 BC. And the first scientific record was actually done by Tycho Brahe in 1677 AD. And now I would like to tell you little about comet, little about Edmund Halley. He, using Newtonian mechanics, for the first time showed that the comet which appeared in 1531, 1607, and 1682 are the same comet. Before Edmund Halley, there was no idea whether comet is periodic or not.
Yes, again, I am intervening.
Yes.
Some audio problem is there, perhaps.
Audio problem.
Yeah. Echo is coming.
Echo is okay.
Whether other devices are there, perhaps.
Okay, I'll try to minimize the echo.
Okay. Thank you, sir.
So Edmund Halley, using Newtonian mechanics, showed that a comet which had appeared in the 3 consecutive years had 3 different years had the one and the same comet with a period of 76 years. And he was the first person to predict this. So what he did, he predicted that the same comet would return in 1758. The comet did appear in 1758, but comet appeared. But the problem is that the disappointing fact is that the Halley was not alive to see his glorious prediction, and he died in the year 1748. But This famous comet is called Halley's Comet because he for the first time gave us a clue that comet are periodic. And in 1986, this comet last appeared. Means after 76 years, again this comet will appear. So if you look at this picture, you can see that the of comet, the nucleus. Probably I have shown you in the first video. When comet is far away from the sun, then you can see the nucleus, which is around 1 to 10 kilometer in diameter. When it absorbs the heat of the sun, the tail it becomes blow. It will blow like balloon, and we call it coma. And then it will become 10 to the 4 to 10 to the 5. And if it approaches further, then it will become 10 to the 6 to 10 to the 7 kilometer. In this animation particularly, you can see that a comet is orbiting around the sun, and whenever it is approaching towards sun, and the tail is forming, and tail is always away from the sun. In this particular diagram, it is showing. Now the tail of a comet, how many tails are there in a comet? Comet has two tails. So one is ion tail, we call it type 1 tail or plasma tail, another is gas tail or type 2 tail. The tail of a comet is always away from the sun, as I told. Now, great comet of 1843, already I told you that this comet had the longest tail observed till date. It is around 3.3 billion kilometers in length. So if you want to compare this with the distance between Sun and Earth, distance between Sun and Earth is 1.5 billion kilometers, means 15 crore kilometer, and it is almost double the distance between Sun and that comet. The comets are classified into two groups. One is periodic comets, another is long period comets. In periodic comets, already I told you that the comet idea. These are also classified groups. One is short period comet, another is long period comets. In short period comets, it is less than 200 years, and more than 200 years is long period comet. The comet which has in our solar system, comet Neowise, this is actually having orbital period of 2000 years. Sorry, years. Now I'll show you one of actual video comet. Just look, you will get interest to observe the comet. Just look at this picture. One comet is, so here sunlight is blocked. Here sunlight is blocked. So this is sun actually. This is corona graph. Means we are blocking the sunlight, and whatever will pass through the sun, we can see. And this is a satellite picture, and you can see that a comet is passing very close to the sun. And this is comet Hyakutake, which passed very close. And look at the tail. Tail is always away from the sun. Now I'm showing you the animation number 2. Here you can see comets are approaching towards sun, and ultimately they disappeared. Why? Because they came very close to sun, and because of that they could not come out, and we call them as suicidal comet because they made suicide on the sun. Just look, the sun is just the comets are just going inside the sun. So this is the number 3. I'm showing you. So this is actually Mercury, and you can see this comet is coming. Ledge is away from the sun, tail is away from the sun, and ultimately it also could not come out from the sun because of the tremendous gravitational attraction. Last video I want to show you. In the last video, you can see a very nice video. This how the tail is changing in this comet. You can see through this video. Comet is approaching, and then immediately the tail of comet is changing. But remember, these animations have taken many months compile the data. Comet Neowise, because it is in recent. This was discovered in the year March 27, 2020 by NASA's Near Earth Object Wide Field Infrared Survey Explorer, Neowise, and it is a long period orbit. The orbital period of this comet already told you it is 6,800 years, and this comet was visible in the last week of July. Comet Neowise is in diameter, and it has two tails clearly visible in this picture. You can see, and recent study shows that the dust field is at least 16 million kilometers long, and the speed is around 2,000 kilometers per hour. Means that velocity it is actually moving. And if you want to know how much water is there in a particular comet, then I will tell you that around 13 million Olympic swimming pools of water is there. On the NASA scientists actually informed us through a news channel. So this is actually comparison for the general people. So this was the picture, and you can see that in the last week of July, it was visible with the naked eye. From where all the comets are coming. So if you want to know it simply, because time is very short but I'm just telling you, millions of comets actually surrounds the solar system, which are far away from you, and here the scale is there. And you can see that one astronomical image distance is Sun and Earth, and then if you go far away, around 10 to the power 5 AU, then there you'll find this is the boundary of our that cloud, and that cloud is known as Oort cloud, because Jan Hendrik Oort in 1950, only years before, he predicted that the millions of comets actually surrounds the comet and still gravitational bound to it. Suddenly they actually enter into our solar system and observable as a comet. Next question is there any possibility of collision of comets with Earth? The answer is we have observed one such event in 1994 when Shoemaker-Levy 9 broken into Jupiter and ultimately crashed into Jupiter. And after collision, the energy was 10 million megatons of TNT. And if you want to understand that TNT, the Nagasaki Hiroshima atom bomb, which actually destroyed that city, was equivalent to 20,000 tons of TNT. So just imagine many parts of the Earth would be destroyed if it collided with Earth. So I'll show you some photograph. So this is the same comet, but it is broken into different parts because of this tidal forces of Jupiter. And this is the photograph, and you can see that earlier it was a single comet, but it is broken into different parts. Many missions were conducted, but to study Comet Halley and other comets. I'm skipping that one. So this is Comet Halley, and 5 spacecraft. And here this is Giotto. We have 2 spacecrafts there, and this is Giotto. These are 2 Japanese spacecraft. Now, why study comets? Because if we study comets, it can give us information about the origin of solar system. Because it is believed that the comet and our solar system had formed in the same time, around 4.5 billion years ago. And also, origin of solar system, origin of life on Earth is also associated with the appearance of comets. Scientists believe that probably in the long past, one of the comet actually collided with our Earth, and actually comet had all these elements: hydrogen, carbon, nitrogen, oxygen. So because of that, this life has started. So if you want to understand this, there is an experiment. It is Miller experiment. Those who are in biology, they know it. That if you take a mixture of ammonia, methane, and water, and if you pass electric discharge, then organic molecules are formed. So we believe that maybe the same phenomena could have produced in the early stages of the leading to formation of life on Earth. So scientists believe that comet may have brought life on Earth. So these are all detected in Earth, all the elements, and energy instead of electric discharge, it was solar wind, solar ultraviolet radiation comets in the process of chemical evolution finally led to formation of life on Earth. So what I want to tell you that if you study comets, it will give you information about the origin of comets as well as origin of life on Earth. Last but not the least, let's look at this picture. It was actually recently when comet Neowise was visiting one couple. Actually, they got engaged under a rare comet Neowise. So this was actually yesterday I collected from one of the news portal, insider.com, and I think this is a nice photograph which we could actually believe that everything goes fine. And the last but not the least, I should tell you that the appearance of comet Neowise is nowhere related with the appearance of this corona. People also telling that since comet Neowise has appeared, the corona is appeared. It has nothing to do because the appearance of comet is a natural phenomenon. It has nothing to do with any unusual event. Thank you very much.
Thanks a lot, Dr. Himadri Shekhar Das, Assistant Professor, Department of Physics, Assam University. Now, time for interaction. So many questions we have received from the participants, but as we are running short of time, so we will not be able to take all the questions. So few questions and few queries are there. Sir, on behalf of the participants, I am putting those questions or queries.
Yes, sure. You may ask the question, Raghu sir.
Gyandeep Devnath, one of the student, he asked why the orbit of comets are highly electrically eccentrically elliptical and differ from the shape of planets.
Okay, so let me tell you that comet is coming from a region. Already I told you that comet is coming from a region. It is known as word cloud. So actually, the eccentricity depends on the orbital characteristics of the comet. And probably when I classified the list, probably you have seen that eccentricity defines the orbit. So if it is less than one, it will be elliptical, and if it is equal to one, it is parabolic, and more than one is hyperbolic. Very few comets are parabolic, but many we have observed has eccentricity more than is equal to one means parabolic. So this eccentricity depends on the orbital characteristics. If a new comet is coming, then eccentricity is normally very high. But those who are trapped in the solar system, their eccentricity is less, and they are more circular. They're more circular means less elliptical because of the
Is it due
location of
to
ground.
energy that the comets which are coming fast, they are having more energy? That is why their eccentricity is less. Is it the cause? Energy
Now,
factor
this
is
is
there.
definitely because when we study the orbital characteristics, energy is always there. Energy factor is there, but that depends on the attraction between different planets. Because if it is coming very close to Jupiter, then Jupiter has tidal poles. Okay.
Okay.
Then if it pass near to Saturn, it has also tidal poles. Then what happens? The velocity will increase.
Yeah,
Okay.
yeah.
Many factors are there. Not only because they don't have a specific orbit. So many factors are there. Location of different planets are also important when a comet is coming.
Okay. Nice. So another question I am taking, Deepak Nath.
Okay.
He was our friend also. So he put one question. Do we really know where comets and asteroids go once they leave our space? The
Okay,
question
probably.
is, do I repeat?
No, I have understood. Deepak, after long break, we are meeting
Yeah,
in the
yeah,
virtual platform. So thank you very much for asking me this question. So the answer to your question is we need to find whether comet is coming from what cloud. What cloud means I'm telling you that what cloud is a part of our solar system. The comet is always there. And sometimes new comet enters into a solar system and then just revolve around sun and again come back to the original location. So sometimes they again come back and sometimes they don't come back. They resides there for a long time. So this is one case. And another case, recently it was actually studied. It is hyperbolic comets. In case of hyperbolic comets, the comets may come from other star system, nearby star. Another comet is coming. So in that case, comet is visiting our solar system. So he is visited to our solar system. And two comets recently visited. And we have detected that two comets. And we believe that these two comets actually came from another star system. They are not part of our solar system. I think the answer is clear.
I think the participant uh, will have got the idea. Oh, the answer is clear to him now. So, do I put another question? Last questions
Yeah,
that
sure.
I'm.
Sure,
Uh,
sure. You can ask question, no problem.
yeah. So many questions are there. A bundle of questions and
Now
queries
it
are
depends
there.
on now it
Yeah.
depends on time because lots of
Yeah,
people
yeah,
are
yeah.
waiting.
Time constraints is
Yeah.
there. That is why we will not be able to take all the questions. So sorry.
Yes, yes, yes.
Uh, so I am taking the last one from this presentation. Then Olokesh Dash. He
Okay.
put a question. What is Omusoma? OMUAMUA.
Oumuamua. It is
Hmm.
Oumuamua.
Acha,
Uh, uh,
Oumuamua. Anyway,
Oumuamua. So this is a meaning of visitor. I was talking about hyperbolic comet just now. Two hyperbolic comets recently visited our solar system, and this came from another star system. Just now I called, na. So this Oumuamua, it looks like a cigarette, and people believe that this comet came from another star system. And orbital characteristics tells us that this is a hyperbolic comet. So Oumuamua is a hyperbolic comet.
okay. So thanks a lot to
Thank you
Dr.
very much.
Dash for enlightening
Thank you
us
very much.
regarding comets. We have come to know so many things from comet, and particularly the young students, enthusiastic students, have got idea about the comets, and hope they will pursue their higher studies or research work on comets, on the unexplored part of the comets in the days come. Thanks you, sir, once again.
Okay, so I'm just leaving this platform because I can see this in YouTube because lots of speakers will be joining. So I'm just leaving out from this room and join in Google, YouTube because live telecast is going on YouTube. So I'll join there. Thank you very much for inviting me.
Okay. Okay, thank you, sir. So the second invited lecture, the lecture would be understanding the mysteries of the universe, a visit through darkness. Dr. Sudipta Das, Assistant Professor, Department of Physics, Vishwabharati University, Kolkata, West Bengal. So, before inviting to Madam, I would like to share few words to the participants. So, there are so many things to say, but as we are running short of time, so I am just sharing few words about Madam. Dr. Sudipta Das, Assistant Professor, Vishwabharati University, Shantiniketan. Madam Das was awarded prize in Young Physicist Colloquium in the year 2007, organized by Indian Physical Society. She also won the V.V. Narlikar Best Thesis Award competition organized by Indian Association for General Relativity and Gravitation in 2009. Madam published lots of papers in national and international thesis. She is actively involved herself in research work. So I now request Dr. Sudipta Das, Assistant Professor, please deliver your lecture, madam.
Thank you very much.
That's madam.
Am I audible?
Yes, madam, you are audible.
Okay. Thank you. So I would like to first thank the organizers for giving me this opportunity and inviting me to this webinar. So, so I am from, although I am settled now in Shantiniketan, but I am from Karimganj, so it's my hometown, and so it's my great pleasure to be a part of this webinar. So today I will be talking about the mysteries of the universe and journey through darkness. So I am sharing my screen, and hopefully we will be able to see it. So can you see it? Hello.
Yes, madam.
Okay.
Nicely visible.
Okay, thank you.
Please continue, madam.
Okay, thank you. So today I'll be talking about understanding the mysteries of the universe, and I will be mainly talk about the dark sectors of the universe. By dark, I mean about the sectors of the universe about which we don't know. So I'll be talking about mainly two major dark components of the universe. The first one is dark matter, and the second one is dark energy. So I will be talking about the method of detection of these two components, the dark matter and dark energy. And I will be mainly talking about how do we come to know about the existence of these components. I will specially put emphasis on the meaning of the word dark, what we mean by dark. And then finally, I'll talking about a few days of hope. What the future experiments that are going on or will be operational in near future. What are we expecting from this coming observations, and whether we have any few days of hope in this dark universe. So let us begin our journey through darkness. So this is a typical night sky. We look at it every night when it's a clear sky. We have the stars and moon and some planets that we can see with our naked eye. Now suppose I provide you with a powerful telescope. So the powerful telescope, the same sky, it will look something like this. So this is the picture taken with Hubble Space Telescope. And here you can see each of these tiny dots that you can see. These are all basically a galaxy. And you can see here you have a spiral galaxy. Here this is an elliptical galaxy. So we hopefully we know that there are these galaxies. They are basically of different shapes. Some of the galaxies, they are spiral in shape. Some of the galaxies, they are elliptical in shape. Some of them have some other peculiar shape and so on. So, but most of the galaxies that we see in the universe are either spherical or elliptical. And our Milky Way is basically a spherical galaxy, barred spherical galaxy. I'll come to it in. So if we have a powerful telescope, the sky will look to us like this. If I look at the sky with a even powerful telescope, then the sky will appear something like this. And this is also an image taken with Hubble Deep Survey Telescope. And all these tiny dots, these are basically one galaxy. Here, these are all these lights are one galaxy, like our Milky Way galaxy. So you can see that there are innumerable number of galaxies. There are millions of galaxies that we can see with a powerful telescope. And to give an idea of how big our universe is, let us talk about the cosmological scales. We know that the distance between the Earth and the Sun, it is 8.5 light minutes. That means the light, it takes 8.5 minutes to reach from the Earth to from the Sun to the Earth. A typical galaxy like our Milky Way galaxy, it contains of the order of 10 to the power 10 number of stars. Mass of our own galaxy, it's of the order of 10 to the power 10 solar mass. Size of our galaxy, this is around 30 kiloparsec in diameter. So this is an artist's impression of Milky Way galaxy. Obviously, we cannot take the picture of the Milky Way galaxy because we cannot go out of the galaxy and take a picture. So these are all computer simulated images. So this is the face-on view of the Milky Way galaxy, and this is the edge-on view of the Milky Way galaxy. And we know I should mention that our sun or our solar system, it is not somewhere near the center of the Milky Way galaxy. Rather, we stay somewhere on the side of the Milky Way galaxy. We are near one arm of the Milky Way galaxy, of the spiral galaxy. So you can see this is a spiral galaxy. It is a bar. There is a bar-like structure, a rod-like structure, and from the two ends of the bar, the spiral arms come out. So that's why it's called a barred spiral galaxy, our Milky Way galaxy. And here is our solar system located. And the size of our Milky Way galaxy is of the order of 30 kiloparsec. What is kiloparsec? 1 parsec is 3.26 light years. 1 light year is of the order of 10 to the power 16 meters. So 1 kiloparsec is of the order of 10 to the power 22 meters. So our Milky Way galaxy is this diameter wise, it's around 30 into 10 to the power 22 meters. And I must mention that our Milky Way is basically a moderate sized galaxy. There are many more galaxies in the universe which are much bigger than our Milky Way galaxy. So this, as I have shown you in the previous slide, there are a number of galaxies around us. So how big is our universe? To get an idea of this, let me show you a video. So this is our Milky Way galaxy, obviously a computer simulated image of our Milky Way galaxy, and our solar system is located somewhere over here. So this is our Milky Way galaxy, and we are somewhere over here near one of the arms of one of the spiral arms. And this Milky Way galaxy is basically a member of something called, we call it a local group, where we have many such other galaxies like Andromeda and other galaxies. This local group is a part of this Virgo supercluster, and here each of these tiny dots is basically a galaxy cluster. And our Milky Way galaxy is somewhere over here. This local group cluster, it is somewhere over here. And this Virgo supercluster, the size of this Virgo supercluster is around 110 million light years. This Virgo supercluster is again a part of this big Lanakia supercluster. So here is our Virgo supercluster located. So you can see that it's a very tiny part of this entire Lanakia supercluster. And this Lanakia supercluster is around 520 million light years in size. And this Lanakia supercluster is again a part of this observable universe. So if we consider this to be the total observable size of the universe, our Virgo supercluster is just a tiny point in it. So you can imagine that where we are situated in the universe. It's a very, very, very tiny part of the observable universe. So for such a big universe, what we have is basically filled with innumerable number of galaxies. So what we see when we look into the sky, we know that the universe is filled with many such galaxies. And Edwin Hubble in 1924, he actually showed that each galaxy, as we know that our Milky Way galaxy is basically a collection of stars and gases. So all these galaxies that we see in the universe, they almost have the same in material. Means all of them are basically collection of stars and gases, just like our Milky Way galaxy. Now the question is, what are the stars and galaxies are made up of? So for that, let us go back to our class 11, 12 days. We have studied fission and fusion reaction in our class 12 days, and we know that inside the sun, this fission reaction takes place. This neutron and proton, they combine to form deuteron. Deuteron again meets with proton to form hydrogen and helium and other heavier elements. And so we know that inside the stars, there are basically mostly hydrogen, some amount of helium, and other traces of heavier elements like lithium, deuterium, iron, and so on. So most of the stars, they are made of this hydrogen, helium, and others. Now the question is, and we know that all these galaxies are made up of these stars. So mainly they are rich in hydrogen and helium. Now the question is, how do we know that what we are seeing, that is all that is there in the universe? We can see the galaxies. By seeing, I mean that they are emitting some kind of light, not only visible light, it may be electromagnetic, any kind of electromagnetic radiation, x-ray, gamma rays, infrared waves, anything, any kind of electromagnetic radiation. If the galaxies or if the stars in the galaxies are emitting, we can observe them through our different kinds of telescopes, X-ray telescope, radio telescope, or optical telescope, whatever it is. So the question is that all that we are getting from the universe, or there is something invisible, which by invisible I mean that it is not emitting any kind of electromagnetic radiation? Is there any kind of stuff which is not emitting any kind of electromagnetic radiation, but it is present in the universe? And if this type of stuff is there, then what is the way to detect those stuff? And the answer to this question is, one can detect those invisible things by with the help of gravity. Nothing can hide from gravity. So I'll explain this picture in a moment. So what do we mean by invisible stuff? By invisible, we mean that this does not emit any electromagnetic radiation. Now, how to find out this object which is not emitting, or how to detect this object which is not emitting any kind of electromagnetic radiation? So for that, let us let us take the help of the Einstein's equations. So don't worry about this equation. I'm not going into the details of this equation. I'll just tell you the equation in the like a story. So suppose this is our universe, the space-time, we call it the space-time. Now this space-time, one can think of it, how Einstein explained it, we can think of it as a rubber sheet. Suppose this is a rubber membrane. And you put, suppose I have a heavy galaxy, a galaxy which is heavy, it has got some mass, and I put it on the rubber sheet. You know that if you put a heavy ball, iron ball on the rubber sheet will get stretched and it will become curved. So if the rubber sheet it becomes curved at those portions where you are putting this heavy rubber ball. So when you put this rubber sheet becomes stretched and curved. So if you have another small ball nearby this bigger ball, the small ball will obviously, since this rubber membrane itself is curved, so the small ball will move towards the rubber ball. Now in our school days, we have learned that there is something called the force of gravity, Newton's force of gravity. We know that because of the force of gravity, every object it attracts every other object. But here, according to Einstein, there is nothing called the force of gravity. There is no force of gravity. Everything happens because of this curvature of this rubber sheet, curvature of the space-time. This space-time is basically the rubber sheet. So since the space-time gets curved because of the presence of a galaxy, other galaxies or any other object will follow this curved or this stretched space-time and will move towards the heavier object. So this is what this Einstein equation tells us. On the right hand side of on the left hand side of Einstein equation, we have this G mu nu. Forget about this actually represents the geometry part. So this represents basically your this rubber sheet. And on the right hand side, we have this something called the steam union. The steam union, it represents the matter. So it represents all these galaxies, these heavy iron balls, which make this rubber sheet to curve. So the meaning of this, or the gist of this Einstein's equation, is that matter tells space-time how to curve. You put a matter, it will tell the space-time how to get curved. And once your space-time is curved, this curved space-time will tell other matter to move, how to move. So matter tells space-time how to curve, and space-time tells matter how to move. Now, this concept is actually used in detecting this unknown star. This is because when you have this curved space-time, obviously everything that you have in the universe, because this is space-time for the universe, everything you have in the universe will follow this curved space-time. And when I say everything, it includes photons also. That means light also will follow a bent path. So as space-time gets curved, everything will follow a bent path, including the photons. So light will also get bent. And this bending of, and this has been experimentally observed, this bending of light has been experimentally observed. So this bending of light will actually, this phenomena is used to detect whether there is any invisible mass in the universe. So what is this? This effect, or this technique, we call it in the language of astrophysics, we call it gravitational lensing. So let me explain this concept to you in using this cartoon. So suppose you have a galaxy and it is emitting light. So we know that these galaxies, it will emit light in all directions. And suppose something, some missing matter, we are not being able to see it, we are not being able to detect it with any of our telescopes. So this missing matter, it is sitting over here. There is something which is which we are not being able to detect. Now, light from this, obviously, if you have a heavy mass sitting over here, the space-time around this portion will be bent. So the light which is coming from this galaxy, this will also get bent. The light which is coming from the other direction, that will also get bent. But here, suppose we are observing from this observatory, our telescopes or our eye, it cannot follow any bent path. So what we'll say, our eye will see a eye will to our eye, it will appear as if this galaxy or the star, it is situated somewhere over here. Corresponding to this bent path, the star will appear to be, or the galaxy will appear to be sitting over here. That means we will see multiple images of the same star. And this is what is known as gravitational lensing. So because of this lensing effect, we can see multiple images of the same object. In fact, if there is a very heavy mass sitting over here, the space-time will be bent, the curvature will be so large that we sometimes see a continuous ring-like structure. So this is a photograph taken with this is an actual photograph taken with a telescope, and you can see that we almost see multiple images of the same thing, and it almost, because this is a heavy mass sitting over here, so we see multiple images of the same star, almost a ring-like structure. This is another object. This is another real picture. So you can see that multiple images of the same star you are getting. This is one of the very nice diagrams. So this is the photograph taken near the Abel cluster. So this is Abel group of clusters, and you can see the multiple images of a galaxy you are seeing around it. So this tells us that this gravitational lensing is a real phenomenon. One does actually observe this type of effect. Now the question is how this lensing effect. So with this lensing effect, one can actually find out how much amount of mass is there from the circle, and how many images are formed. From that, one can actually calculate what is the amount of mass that is sitting in the sitting over here in the path of the star. Now the question is, how can these galaxies help us in detecting these unknown masses? So for that, let us take this example. So suppose this is the cartoon picture of a Edge-on galaxy, Edge-on spiral galaxy. So like our Milky Way galaxy. So this is a Milky Way galaxy. So this is the edge-on view, and we know that for to remain in equilibrium, this spiral galaxies or any heavenly object, it has to rotate about its own axis. Otherwise, they will fall into a gravitating matter. So this Milky Way galaxy here, it is rotating, or any spiral galaxy, it is rotating about its own axis. Now when it is rotating one arm, suppose I am viewing from the front, so one arm it will come towards us and the other arm it will go away from us because it is rotating around us. So if it is moving away from us, the end which is moving away from us, or the part which is moving away from us, that part of the galaxy will be red shifted, and the part of the galaxy which is moving towards, or the spiral arm which is coming towards us, that will get blue shifted. That means we basically observe the Doppler shift. So let us go back again to our HS classes. Why do you observe this Doppler shifts? We have done many such examples in our HS classes. We know that when a car or a object is, or a train, when it is approaching us, within the small space, a large number of waves gets compacted, and so the wavelength decreases, and because of this, the frequency increases. So we get a higher pitch. On the other end, when it is receding away, the wavelength it basically increases, and when the wavelength increases, we get a lower pitch. Same thing happens for the galaxies also. So if you have a luminous system, if the luminous system or if the galaxy is approaching you, so that part which is that end of the galaxy which is approaching you, the pitch will increase, the frequency will increase, so we will get the wavelength towards the bluer side, and when we get the frequency is decreasing or the wavelength is increasing, we'll get it on the redder side. So this is what we mean by redshift and blue shift. So when the galaxy is moving, it will either one end of the galaxy will be blue shifted and the other end will be red shifted. And from the frequency shift, from the Doppler shift, how much is the change in frequency, one can actually find out with what velocity this object is moving. So to understand this rotational, or to understand this how this is calculated, let us talk about something called the rotation curve. So let me give you a very simple example to start with. This is a merry-go-round, and we have all of us have taken a ride in this merry-go-round. And in merry-go-round, if you remember, we always used to prefer to sit on the outer side. This is because we know that the horses which are on the outer side, they move with higher speed, where the inner ones they move with lower speed, because in the fixed time this both these points will come in the same point, so this will move with a in a smaller circle, so orbital velocity will be lesser, and if it is moving in a larger circle, so its orbital velocity will be more. So if you plot the orbital velocity with respect to distance from the center of the merry-go-round, you will get a curve something like this. So this type of curve, where we put orbital speed as a function of distance, we call it a rotation curve. So what will be the rotation curve for our solar system? For our solar system, we know that the most of the mass is concentrated near the sun. Most of the galaxies are near the sun, and most of the planets are near the sun. And on the outer skirt, we have on the outer side of the solar system, we have very few number of planets. And if we look at the Newton's equation, we know that the force due to gravity is basically gmm by d square. So where you have more mass, the force will be more, and in this force it has to balance the centrifugal force mv square by r. So where mass is more, the velocity will also be more. So a smaller force means a lower orbital speed. So where the force is more, the orbital speed will be also be more. That means towards the inner side of the solar system, the orbital velocity will be higher, and towards the outer side, the orbital velocity will be lesser. So this is the rotation curve for our solar system. For spiral galaxies, also a similar type of rotational curve was expected, because in the spiral galaxies also, most of the mass is concentrated near the center here. And on the outer skirt, we have mainly gaseous objects and few stars. So it was expected that we will get a solar rotation curve for the galaxy similar to that of a solar system. That means it will fall down as we move away from the center. But how to measure the rotation curve for spiral galaxies? So to this, the strategy which is used is, suppose you have this spiral galaxy and it is rotating. So what we do is we divide this spiral galaxy into a number of small strips, and for each strip, suppose this is in some equidistant strips, and for each strip this distance is suppose some r, and for each of this r one can measure either the blue shift or the red shift depending upon which portion you are looking at. And from blue shift, for this much portion one can observe the blue shift and red shift, and from that one can actually calculate what is the orbital velocity. Similarly for the next portion and so on. So So for all these strips, one can find out what is the velocity of these individual strips. Once we know this, obviously, if I know velocity, one can actually calculate how much mass is there in the galaxy. So for each v of r, one can calculate mass of that small strip, and by adding all these masses, one can find out what is the total mass of the spiral galaxy. So when one actually plotted this rotation curve for the spiral galaxies, as I told you that it was expected, this was the expected curve, that one was expecting that the orbital velocity will fall off as we go from away from the center of the galaxies. But what was actually measured was that the orbital velocity was much more. The orbital velocity did not fall down, rather it remained almost same even when we moved far away from the center of the galaxy. So if you have higher orbital velocity, if I look at the previous slide, if you have higher orbital velocity, that means you should have more mass. So whatever mass we calculated for this spiral galaxy, it was found that the orbital velocity, the rotation curve of the spiral galaxy, it actually indicated that there is much more mass that is sitting inside the galaxy rather than what we are observing. And this actually led to some missing mass problem. So what we found that the higher velocity, it indicates more mass, and we could not see or we could not detect from our redshift or blue shift from the Doppler shift this much amount of mass. So there must be some missing mass in the galaxies. Otherwise, one cannot have such high orbital velocity. If you have to account for this high orbital velocity, one should have this missing some more mass inside the galaxies. So what it could be, what we have found that these galaxies are spinning too fast, the orbital velocity is much more. So there are two possibilities. Either there is something wrong with the gravity, that means you have to modify the Einstein's equations, but that is, people work on that ground, but this is not a very useful thing because there are many more experiments which support this, which are in favor of this Einstein's equation. So what is the other option? There is more matter than we can see. We are not being able to see what is the visible matter that we are actually seeing or accounting for does not comprise the whole of the story. So there must be some more missing matter, and that missing matter we name it as dark matter. And this was actually detected around 1931, this concept, and Zwicky first proposed this concept of dark matter. So what do we mean by dark? That it doesn't emit any electromagnetic radiation, otherwise we could have detected it. It does not interact with normal matter. Again, if it interacts with normal matter, we can have we have various detection process, but we could not detect anything. So this tells us that it does not interact with normal matter. Otherwise, its properties are similar to normal matter. By normal baryonic matter, I mean the stars and galaxies and others. And this is an artist's impression of how much dark matter we know. So suppose this is our visible galaxy, and this shadow or this halo-like thing it actually gives us a measure of the amount of dark matter we need to account for such orbital velocity, such high orbital velocity. If we want to have such high orbital velocity, we need this much amount of dark matter around a particular galaxy, which we haven't been able to detect till now. So regarding the nature of this dark matter, what may be the component, what may be this dark matter, we are totally in darkness today. Lots of research is going on in this field, but we don't know much about the uh, properties of this dark matter component because we are not being able to detect any feature of it. Now the question is it enough? Was it enough dark, or there are some more dark components in the universe? And the answer to this is yes. There is another component, another dark component, which we name it as dark energy. And this has been detected very recently, around some 20 years back. In the year 1998-99, this was detected. And this dark energy, it resembles the dark matter in the sense that both of them are dark. That means they do not emit any kind of electromagnetic radiation, so we are not being able to detect it. And this dark energy tells us that our universe is rather expanding with an acceleration. Our universe is growing bigger. The space-time, the rubber membrane, the rubber sheet is expanding with an acceleration. So how do you detect this dark energy? How do you came to know that there is something called dark energy? So the dark energy, the detection of dark energy is actually came from something called the supernova type 1A, and we call it the standard candles. So What is a standard candle? This is basically a tool used in astronomy for measuring distance. So I'll give you a very simple example. Suppose you have a candle. It's a normal bright candle. So its luminosity is known. We know how much light a particular candle can emit when if it's of the same size and same thickness. So suppose I move away with this candle, then obviously to us the candle will appear dimmer. If I move further away, it will be more dim and so on. So when I'm looking at this candle here, it appears to be dim, but it doesn't mean that the luminosity of the candle has decreased. Its absolute luminosity remains the same. It appears to be dim. Why does it appears to be less luminous? Because it has moved away from us. And so this its absolute luminosity remains the same, but its apparent luminosity decreases. So if we know how much bright this candle actually is, and if you can measure how much dim it appears, from these two, by comparing these two, one can actually find out what is the distance of the candle from us. So this type 1 is supernovae. This is one such standard candle. So what is type 1 is supernovae? This is basically a white dwarf star having some companion. So if you have a white dwarf star, this is basically a star. When once it dies, then it becomes, depending upon the mass, it becomes a white dwarf star. So when the white dwarf star, if it has got some companion, that means it has got a companion star, then it will, once it dies, it has got huge amount of gravity. So it starts accreting matter from its companion. It starts sucking matter from its companion part. Once it accretes enough amount of matter, since it doesn't have any fusion reaction or fission reaction going on inside it, so it cannot hold that matter and it explodes. So when this explodes, it gives a tremendous amount of light and energy, and so we get huge amount of light. So this is an example of this is a real picture of supernova 1994D. So it was detected in the year 1994 near this galaxy NGC 4526. It's our neighboring galaxy, and you can see this is a supernova explosion and this is a galaxy, and they're almost equally bright. So when a supernova explosion takes place, it actually can overshadow a entire galaxy also. It becomes so bright. And so if you can detect a supernova type 1 supernova explosion, you can get huge amount of information from it. So what are supernova type 1? They are standard candles. That means their intrinsic luminosity is known. All the supernova stars, they have the same intrinsic luminosity. Their apparent luminosity can be measured, how much light I am getting from that, and from these two one can actually calculate the distance. However, there are some associated issues with detection, because you cannot in the sky, you cannot predict when a supernova explosion will take place. And for that, actually in 1998, this team, Supernova Cosmology Project team, and another team, HiJet Supernova Search team, these two teams, they actually uh, found out a strategy, very useful strategy to detect this supernova explosion. So what they did is, suppose this is your sky, we take a patch of sky, this small patch of sky, and they stared at this patch of sky for a long time. Usually the supernova explosions, they last for some 15 days or 20 days. So what they did, they looked at this patch for some 3 weeks to 4 weeks, and after 3 weeks they again looked at this same patch again. So they actually did this continuously, and when they then they took this picture. So this was a picture taken 3 weeks before for this small patch, and this was the picture some 3 weeks after, and then they subtracted these two pictures pixel by pixel, and from this subtraction they could detect from the difference they could detect a supernova explosion. If a supernova explosion is there, then it will be very bright for 15 days, and after that it will again become dim. And by following this strategy, they did this entire sky survey, and they could detect some 527 such supernova detections, supernova explosions, and they actually did this survey for around some 10 to 12 years. And once they got this supernova surveys, they, for each of them, they found out the absolute luminosity, they found out the luminosity distance, and they plotted this luminosity distance against the redshift, whatever, how much amount of light is coming from. Now, this I'm not going into the details of this picture, but this picture tells us is that if this picture would have been straight line, then it means that it would have meant that our universe is moving with a constant velocity. But since there is a curve, this curve actually indicates that our universe is moving with an acceleration. Now, if it is, and for this discovery, actually, the supernova cosmology project team, they got Nobel Prize in the year 2011. So what we found from the supernova explosion, that this universe is actually accelerating and it is not slowing down. Rather, it is expanding with an acceleration. So what it could be, again, now our universe is expanding too fast. It is expanding very fast with some acceleration. So again, there may be two options. Either there is something wrong with the gravity, so one has to modify gravity and see whether it is, or there is some other substance which is actually pushing this. Now, for example, suppose you have a car. If you want to accelerate the car, you have to apply the accelerator. You have to apply some force. So there must be some. So the other option is there may be some driving force which is pushing this, which is giving this gravitational push, and is because of which our universe is accelerating. And this object, this unknown object, which is giving this gravitational push, is known as we call it the dark energy. And why dark? Because we haven't detected any such object till date, but it is giving, but acceleration of the universe, that has been detected. And so there must be some unknown component in the universe which is providing this acceleration, and that unknown component is known as the dark energy. What is the status of the dark energy survey? So this, unfortunately, this is our status. We are trying to look into this dark energy, the candidate, what can be a dark energy. So there is a number of options are being looked at. People are looking for various types of options, and there are some thousands of papers. I myself, I work on this field, and there are a number of works going on this field. But till date, no one can say for sure what actually dark energy is, what it is made up of, because we haven't detected anything about the dark energy. We are just giving prediction that this may be this type of a component, but nothing concrete is known about that. So, what is the status of this dark component? This is a very frustrating picture actually. So, if I consider total energy budget, this is the matter component. The experimental data what we have tells us that around 23% of the universe is made up of dark matter. Because I have shown you this picture that the visible galaxy is very small, and the dark matter that we need for the high of speed is huge. So we need around 23% of the dark matter. Around 73% of the universe is made up of this dark energy component, which again is a very huge amount. So regarding the dark matter, what it is, we don't know. Regarding the dark energy, what it is made up of or what it is, we don't know. So how much we know about the universe? This 4 to 5% of the universe is known to us, and this 4% actually comprises of all the stars, all the galaxies, all the elements that are known to us. So we only know about the 4% of the 4 to 5% of the universe is known to us, and the rest 95% of the universe is known to us. So is scenario, is there any ray of hope? So many surveys are basically going on around the world. So I'll just talk about two. One is the survey telescope, which is being built at Fermi. The primary objective of this is to study the dark matter component and little bit of dark energy, and it is now being done. So the primary objective of this is to count the galaxy clusters and gravitational lensing to know more about the dark matter distribution. But we are hopeful that once it becomes operational, we will come to know about it, the dark energy, the dark matter component more. Regarding the dark energy, the cosmologists are very enthusiastic about it. So this is the 30-meter telescope, which is now being built in Hawaii. And this is the biggest telescope is being built till now. The size of this optical mirror is around 30 meters. That's why it's called a 30-meter telescope. And the primary objective of this 30-meter telescope is to look into the dark matter, dark energy. So since it has a very wide telescope, wide field of view. So it will be looking into the more number of supernova explosions, and we are expecting that if we have more data, we will be able to know about the dark energy component in near future. So it is likely to be operational in 2000 to 2022 or 23 around. So this is an artist's impression of the 30-meter telescope. So it's a very look into the dark matter structure, if the energy component, more number of supernova explosions, and so. So till then, until and unless we get more information from the dark matter telescopes or dark energy telescopes, we are in darkness till now. So we are looking forward to this day. So hopefully we will be
A little
in
audio
coming days we
problem.
will get to know more about these components of dark matter and dark matter. And there is huge scope of research in this field, and it's going on all around the world to know more about these components of dark matter and dark matter. Till now, nothing concrete is known about this component. So, thank you, and this is all that I wanted to share. Thank you.
Thank you, madam. Thank you, all the participants also. So, this is for interaction session. Too many questions we have received from the participants. Many questions are very similar, and as time is short, so I am taking few questions. Madam, Onirban Kaur put in
Yes.
question: is dark matter composed of black holes? His question
Well,
is dark matter composed
yeah, yeah,
of
yeah.
black holes?
Yeah.
Yes or no, ma'am? Yeah.
I Yes, yes, yes. But the thing is, the amount of the number of black holes we have detected till date cannot account for so much amount of dark matter. Black holes were considered as a possible candidate for dark matter.
Excuse, madam. Excuse
Hello.
me, madam. Your
Yes.
audio
Yes.
is disturbing. Audio is not working properly.
Okay. So now is it clear?
It's now a little bit
Is
clear.
it okay now?
Yeah, it's okay. By
Okay.
and large, okay.
So what I so
The
what I am
next
saying is
question,
this black.
ma'am. Next question from Rajdeep Roy.
Yes.
Does dark matter imply dark light? His question or query with
Dark
that
matter
imply dark light. Rajdeep Roy,
dark light.
yeah, Rajdeep
Yeah,
Roy,
yeah.
putting his question: does dark matter imply dark light?
We don't know because we haven't. When we say light, by light we mean any kind of electromagnetic radiation. But this dark matter, as I told you, doesn't emit any electromagnetic radiation. So we don't know whether it's some kind of photon or anything. In fact, it's related to the previous question also. Means people thought earlier that maybe black holes are dark matter. Then neutrinos are also considered to be a component for dark as candidate for dark matter, but nothing is known for sure. All these candidates have their own pros and cons. So nothing concrete is known about the nature of dark matter.
Yeah, ma'am. Another question from Deepayan Shambhumik. Is it possible to travel to another universe or another time by wormhole? If yes, how?
Okay, this okay. So this
Yeah,
wormhole is basically, yeah, I must tell you, this wormhole or black hole again, I must tell you that these are all geometric components. Black hole is basically a the wormhole is basically a geometric counterpart of the wormhole. So this is good in scientific fictions, but in physics, wormhole doesn't play a very important role. The scientists, they do not believe much in the wormhole. It's good mathematically, but physically we do not have anything like the evidence of wormhole. We have evidence for black hole, but we do not have any evidence for wormhole. So it's just a mathematical concept, and we don't know anything about it. The scientists
Oh,
believe that there is nothing like wormhole.
okay, ma'am. Then thanks a lot for
Thank
enlightening
you.
us
Thank you very
regarding
much.
the universe. I think students got the interest on this particular topic, and they will show their interest in the days comings also. Thanks once again from organizing committee.
Thank you.
Madam.
Yeah, thank you all of you for inviting me. It was a very nice experience. Thank you.
Okay, thank you. And from participants, we are not able to take more questions, though there are so many queries, so many questions are there. So hope in the next lecture, I try to take few more questions from other participants too. Now the third invited lectures from Dr. Ratan Das, Assistant Professor, Department of Physics, Tripura University. The topic being X-ray diffraction analysis of nanomaterials and its applications. So let me introduce Dr. Ratan Das, Assistant Professor, Department of Physics, Tripura University. Yes, time is short, so within very few years, I would like to say something about him. Dr. Das did his post-graduation from Delhi University and from Assam University. He is actively associated with research work. His research work particularly has interest on the synthesis, characterization of nanomaterials like metals, semiconductors, and composite materials. And he published more than 60 papers in national and international repute journals. He is actively associated with teaching learning process and research work. We are lucky enough that we have with us with one of his direct research scholar, Piyush Chandra Day. Behind the screen, he has done a lot for making this program success. And we have come to know that he learned so many things apart from the research work from other fields also. That is why very successfully he has coordinated and done all sort of things, technical works. So and Ratan Das is my friend also. So I hearty welcome Dr. Ratan Das, Assistant Professor, Department of Physics, Tripura University. Please, sir, share your speech. Share your lecture.
Thank you, Raghu. Thank you, Raghu sir. I am very happy that I am associated with you through this webinar, and all the organizers have done an excellent job that they are organizing such a beautiful webinar, which will help the students, especially in this region of Tripura. They have listened the beautiful two talks earlier. I shall deliver a talk on nanotechnology related theme. Once again, I would like to give my gratitude to the patron of the program, Srimati Monitipa Devarma, Principal Women College, respected Principal, President of the webinar, Sri Gautam Das, Principal in charge, GDC Dharmanagar, Convener of the program is Dr. Shuma Bonik, Assistant Professor, Department of Physics, Women's College, and the coordinator of this program, especially Dr. Raghuranjan Dash. I'm thankful to all of you. Good afternoon to all of you at the beginning.
And head of the department of our college.
Yes. Head of the department of the college, Dr. Sujit Dash. Thank you very much to all of you. Let me share my screen and let me start my lecture.
Yes, sir. Yes, sir. Having any problem, sir, in
is it visible to you?
Yeah, you are visible.
Screen is visible?
No, screen is not visible yet. Perhaps you haven't shared the screen.
Now I think screen is visible.
Yeah, it's coming. Yeah. It's now visible.
Okay. So the topic is actually slightly different from what you have said. It is the X-ray diffraction analysis of nanomaterials along with electron microscopy study. So these two instruments, actually XRD, X-ray diffractometer, and the electron microscope are very much helpful in nanotechnology research actually. So before starting my lecture, I would like to give some basic background of nanotechnology actually. So as there are lots of BSc students are there, so many of them do not know the background. So it is for them. Those who know, I beg a pardon for them. But those who do not know, it is for them actually what is nanotechnology, what is the behind the nanotechnology is. So nanotechnology is nothing but the production, characterization, and designing, as well as application of nanomaterial in different fields. In other words, we can say it is the science and technology of manipulating atoms and molecules to make new materials in the dimension between 1 to 100 nanometer, which are called nanomaterial, and that are applicable for different application purposes and devices. In specific, we take the dimension in between 1 to 100 nanometer, because in this region the nanomaterials show their beautiful properties actually, for which these materials are very much applicable in different disciplines. So why nanotechnology? Why do we need this actually? Because the material made out of this technology is lighter, stronger, faster, and smaller, and of course of more durable we obtain. So everywhere nowadays we find some sort of nanomaterials are there in medicine, in electronics, in airspace, and so many part of the technology, or so many in materials we find nanomaterials actually. So just at the beginning, I want to tell you that when Sachin Tendulkar started his career around 1990, roughly we can say nanotechnology started its journey all around the world. And India also is not very far in starting the nanotechnology. So once APJ Abdul Kalam said that we missed the silicon technology, which started around 1960, but we should not miss the nanotechnology. So India is now in a second position in nanotechnology research after China, so far as number of research papers are concerned, if I am not wrong actually. So nanotechnology encompasses every discipline. It is in there: physics, biotechnology, engineering, material science, medicine. Everywhere we find nanotechnology. So nanotechnology actually deals with nanomaterials, nanoparticles. So what are nanoparticles actually? So nanoparticles, we know that these are particles which lies in the nanometer range. But basically, we take the nanoparticles in between 1 to 100 nanometer. So this region actually, this region is smaller than the size of the bacteria. It is almost comparable to virus, and our students, or my students, or generally we work with nanoparticles in between or around 10-20 nanometer, which is much smaller than bacteria and virus also. We deal with that. And for this, for studying this nanomaterial in the region of 1 to 100 nanometer, we need some sophisticated instruments. I shall talk about this later actually. So if you see these particular slides, you see if you see this particular slide, you see if you compare, then nanoparticles is 1 to 100 nanometer, which is less than the red blood cell, which is less than or comparable to virus, and DNA is 2.5 nanometer. Whereas wavelength of red light is 680 nanometer. Many students will know these things well. So why nanomaterials are so useful? Nanomaterial possesses some improved and unique physical and chemical properties which are not there in their bowl counterpart. Okay, so and these properties we found that these properties changes with size of the particle. If we vary from 1 to 100 nanometer, and then this properties changes. And manipulating those building blocks, I mean atoms, we can get the different properties actually. So these nanomaterials are very important, because of the size effect. If we vary from 1 to 100 nanometer, that size changing affects the properties, affects the other mechanical properties or magnetic properties, optical properties as well. So very important thing is the large surface to volume ratio nanoparticle shows, because nanoparticle is very small, and that's why we get for nanoparticles we obtain large surface to volume ratio. I want to cite an example here that what is that surface to volume ratio actually is. If we have a cube of 1 by 1 centimeter, then a cube, then the surface area is 6 centimeters square only. But if we reduce that particular box into smaller sizes of 1 millimeter cube, small cubical box, then that surface area increases to 60 centimeters square from 6 centimeters. Now, if the same box, if we reduce into many nanometer sized cube, then obviously we obtained the surface area will increase, and it is about 60 lakhs centimeters square. So reducing the size, we are increasing the surface area actually. So there lies the beauty. When the surface area increases, the surface energy increases, and the surface reactivity increases. Hence, all other properties changes roughly you can say. You see here an example of gold nanoparticles of different size. If we vary from 1 to 100 nanometer, around 5 nanometer it is showing red color, and if we vary the size up to 100 nanometer, it is showing some violet color type. So changing the size from 1 to 100 nanometer, we are getting different color. Similarly, in the case of semiconductor, varying very slightly from 1 to 10 nanometer, we can different color. Okay, so the semiconductors are very sensitive actually to the variation of size. That's why we can say it is the size effect. You see here the silver nanoparticles. There are many different beautiful colors are there depending on the size and shape of the nanoparticles. Now nanoparticles in general we can classify it as semiconductor nanoparticles, metal-based nanoparticles, carbon-based nanoparticles, and there are some nanocomposites are there. Now actually nowadays around 1990, as you have told you that nanotechnology started its journey only because that around that time, around 1985, many sophisticated instruments started appearing. Suppose transmission electron microscope, scanning electron microscope, X-ray diffractometer is earlier there. So because of the presence of many sophisticated instruments, we are able to explore the properties of nanomaterials actually, and that's why we can say that nanotechnology has started its journey from 1990 onwards only because of the availability of these sophisticated instruments. I shall talk about this specially. So what we did do that with transmission electron microscope or scanning electron microscope, these are electron microscope, we can see the particle because the particle is very small in size. We cannot see with general microscope. And XRD or NMR, especially XRD, X-ray diffractometer, which can determine the structure, whether it is the atomic structure is cubic or hexagonal or any other sort of structure that we can determine from the X-ray diffractometer. UV visible and PL are used for optical property study, and there are some SQUID and BSM. These are some instruments. I don't want to mention it here, but still I am saying that these are useful for magnetic property study. Okay, now very beautiful part that I want to tell many of the students, those who do not know actually, that nanotechnology deals with nanomaterials, and nanomaterials are often we find in nature. These shells actually consisted of different nanomaterials. You see the beautiful butterfly wings that are actually some nanostructures arrangement are there. The peacock feathers. There are some beautiful nanostructures we obtain when we go through into the deep into the structure actually. Say lotus leaf. If we go into the lotus leaf, if we see that there are some that sort of structures are there, and because of these structures, water cannot wet the lotus leaf or around leaves. Okay, so it is the interplay of the nanostructures with the outer world which play the role actually for showing their beautiful nature. Now the lizard also, you see lizard tail, I mean lizard leg consisted of some nanostructures. It has some suction type materials are there. That's why the lizard can move here and there. I am saying all this because many of you do not know about these things. So that particular peacock's feather, peacock's plumage, all these are made of some nanomaterials. Okay. Again, I am saying that the beautiful the butterfly wings, they are made of some. They are made of some cuticles, which are nanoparticles. I mean, nanostructure arrangements are there. Okay, naturally obtained the opals, which are consisted of some silica nanoparticles of around 150 to 300 nanometer in diameter. So these are naturally obtained nanomaterials. And in marine organism, one diatom is not diatomic, but it is a organism which is made of some amorphous silica, where we see or we obtain some beautiful nanostructures are there. Okay. And once again, I want to say that nanotechnology is not new. It is a very started from its journey from very ancient times. See that this is a Likardja scarf. At least it is it is made in 4 AD. So it is very old. It is made by Romans. And you see when the glass shows greenish tint in a reflected light, but if we put a light inside it, it shows the bright light. It is because of the presence of some nanomaterials inside it, or put in the glass, actually glass materials. So these are some structures in the churches made of some silver and gold nanoparticles. I sometimes get astonished about how the nanotechnologists of earlier era, ancient times, they have made all these structures out of silver and gold nanoparticles. This is sometimes this is very astonishing. I think there is a sword. The material is supplied by India. In India, there is a pillar, what is called iron pillar. The lining of that iron pillar is made of some nanomaterials. That's why it is not rusting actually. And there is some porcelain materials which is made of some gold nanoparticles. I don't want to say more about that. There are some churches windows. These are beautiful. Some colors that are made of gold and silver nanoparticles. This one also. And what I want to say is that though earlier nanotechnologists have made nanoparticles or glass made of some nanomaterials mixed up, the birth of nanotechnology, we can say it is made by the Michael Faraday, who for the first time scientifically announced the preparation of nanomaterials, gold nanomaterials, gold colloid. But at that time, there was no sophisticated instrument, so he could not able to study the small material actually. But he said that the color showed by this gold nanoparticles, it is reddish in color. He obtained this. It is this particular gold nanoparticles he prepared actually, and it was so long preserved in the British Museum. So he said, Michael Faraday said he prepared it in 1857. You know, we have started our freedom struggle in 1857, but he made that gold nanoparticle in 1857. So he prepared that nanoparticles, gold nanoparticles, and said that it is because of the smallness of the particle, the color is the colloidal solution. It is showing its beautiful color. So around 1897, one particular person, Sigmondi, started working on gold colloids, and that earlier our nanotechnologists have made the glass made of some gold nanoparticles. He finally declared that it is consisted of some gold nanoparticles, and for this work he was awarded the Nobel Prize in 1925. Actually, and later the Richard Feynman, who is a famous person and the best lecturer in the world so far as physics subject is concerned. He envisioned about the nanotechnology, and he said there is a famous line: "There is plenty of room at the bottom." What is the meaning of that? Is that there lies plenty of room if we manipulate the atom and if we make beautiful structure out of the arrangement of atoms. So he actually he's a visionary, and he talked about that small technology or nanotechnology earlier. APJ Abdul Kalam again said that the long-lasting original color of peacock has come from God's own creation of nanomaterial coated in peacock's feather. So he also talked about that peacock's feather is made of some nanomaterials. So ultimately, I am coming to my lecture schedule actually. So we can prepare the artificial or nanomaterial out of three ways. One is physical method, chemical method, and biological method. Physical method is etching one. Lithographic technique is a physical method where we come down from bulk to the smaller region. There is a chemical process. We find it that we make the nanoparticles out of making or manipulating atom by atom arrangement. And there are some biological methods through which we can prepare the nanoparticles. We generally follow the chemical process because this is a very easy one, and we can obtain easily the nanomaterials. All throughout my career in research, and my students are working or preparing nanomaterials out of this chemical process. Actually, so after preparation, we have to know. We need to know about the size, shape, and crystallinity of the sample. Okay, so here the X-ray diffractometer, the instrument which provides the crystallinity and purity of the sample, as well as the electron microscope which provides the size, shape, and crystallinity of the sample as well. So this is actually the picture of the X-ray diffractometer, where I put the sample here, and there is an instrument. There is a detector which moves around, and it detects the diffracted X-ray after falling on the sample. So it follows the Bragg's law. These are some planes, crystalline planes, where the X-ray get reflected or diffracted, and thereby it makes twisted angle with the detector actually. So that theta plays a very important role, and you see here one plane we are considering, but in nanomaterial or in any material we have different planes, and different planes actually produce different diffracted rays. And these diffracted rays at a particular angle, they make some interference, and thereby there we shall get the peak actually, XRD peak, and it follows the Bragg's law. Twice d sin theta is equal to f, where d is the d spacing that we shall get from the crystalline planes. And the size can be obtained from the famous formula, what is called Sharal formula. What is the size? Size of the nanomaterial. So there are some techniques that I don't want to go in details, but what are the things that in the nanomaterial we have, or in any other material we have different planes, and different planes gives different diffracted beams, and finally we shall obtain a XRD pattern like this. At a particular angle, we shall obtain a particular peak, and again another particular angle we shall obtain peak, and there are some different peak we shall obtain. And all these peaks are actually related to different planes of the crystalline structures. Okay. So basically, if we take the XRD of a bulk material, we get the delta function. This is infinitely peaked XRD peak with no width actually. This is the Fullerton half maxima. If we have a peak like this, and we have the Fullerton half maxima, but here in the case of a bulk material, we don't get generally the peak actually. I mean the width actually. So there lies what I am going back, because here you see in the Scharer formula we have beta. This beta is nothing but our Fullerton half maxima actually. So this is the Fullerton half maxima, and that XRD peak has some Fullerton half maxima. That particular Fullerton half maxima beta and the angle twice theta plays very big role in finding out the size of the nanoparticles. Okay, so moving forward, you see in the XRD line we have some broadening. And that in that broadening we can have instrumental broadening, because there may lie some defects in instrument. So instrumental broadening as there, crystallized size effect are there. So because of the smallness of the size, the broadening actually takes place. I want to go back again to the slides. I have said that for a bulk material we obtain a infinitely peaked with no width. But if we move to the nano region, smaller the size, more the width. So if we take a 100 nanometer particle, the width may be like this. If we take smaller nanoparticle, 10 nanometer particle, the width will be more. So from the width of the particular XRD peak, we can obtain the size using the Scharer formula. So in that particular XRD peak, we have some instrumental broadening that can be nullified by neglecting the instrumental broadening. There are some techniques. We take the instrumental broadening of some known sample, and then substituting this instrumental broadening, we get the broadening actually. So this is not a very big part, so we can get rid of this. But crystalline size, this play a big role in broadening the XRD peak, as well as there may lie some strain, and there may lie some other defects. Because when the particle reduced to the nano size, there are some rearrangement of atomic arrangement takes place, and because of the rearrangement, some distortion in the lattice structure takes place, and because of this lattice structure change, we get some strain in the nanoparticle, what is called intrinsic strain or residual strain, that I can say. So origin of this intrinsic strain is because of the size confinement in the nanoparticle or generation of vacancies and defect states. These intrinsic strains can be calculated from XRD peak width through different methods. All my research scholars are doing these particular methods. There are some methods what are called Williamson-Hall methods, Helder-Wagner method, Seistenbrock method, Warren-Warburg method, Boyd method. All these are methods are there in calculating the intrinsic strain in the nanoparticles that originate because of the size confinement. So following parameters that can be obtained from XRD study. I don't want to go in details, but I can say that the crystalline size can be obtained, crystal structure can be obtained, lattice planes can be obtained, d-spacing can be obtained, lattice constant also, air can be obtained, strain, stress, energy density, all the elastic properties can be obtained from XRD diffraction profile analysis. So these are some the samples, XRD diffraction pattern of our samples, which we have analyzed and we have published. This is related to some silver nanocube, silver nanohexapod, silver nanohexagon, etc. And there are some Williamson-Hall analyses are there through which we can obtain the epsilon, what is called intrinsic strain actually. So there are some techniques that there is no scope to discuss it here actually. And there is a Nelson plot through this plot we can obtain errorless lattice constant actually. So I want to say that through XRD analysis we can obtain all these parameters actually. Now going to the electron microscope, there are two types of microscope. One is a transmission electron microscope and another is scanning electron microscope. This is transmission electron microscope because through the sample the electron pass through or transmit. That's why its name is transmission electron microscope. I am showing my picture here only because to give you an imagination that this particular microscope is very huge, and it has a very huge magnification up to 2 lakhs, 3 lakhs magnification 3 lakhs magnifications are there. So resolution is very high. So why do we need electron microscope? Because generally with the naked eye, I mean that particular resolution difference are there. So we have resolution of 2.2 nanometers are there for the naked eye. For optical microscope we have 0.2 micrometer only. But for electron microscope we have 0.2 nanometer. Because of this resolution we are getting only because of the smallness of the electronic wave. I mean, electron has some wave. When it moves fast, it has some wave, or wave is associated with that electron. That wavelength is very small. We cannot get that smallness of wavelength in the case of visible light or any other light, because in the case of a visible light, suppose the red color is 600 nanometer, whereas the wavelength of the electron is 1.53 or 1.23 nanometer actually. So because of the smallness of the wavelength of electron, the resolution is very high actually. I mean very low actually. So because of this law, because of this 0.2 nanometer resolution, we can get the we can see very small nanoparticles actually. So here you see with the naked eye you can see up to this much, or with the light microscope we can go to the bacteria even. But below that we need some electron microscope actually. So application of electron microscope not only in viewing, we can see the surface structure, but we can also get the composition. That the nanoparticle is composed of what actually. We can get the size and shape also, and we can get the crystallographic information as what the XRD is giving theoretically. So this is the scanning electron microscope. Again, I am showing my image because this electron microscope is a bit smaller. I mean, this scanning electron microscope is a bit smaller compared to the transmission electron microscope. These are some inside view of scanning electron microscope. These are some inside view. Now, what are the basic difference between SEM and TEM actually? The basic difference is that SEM provides the surface topography, whereas TEM gives the inside structures. Especially in TEM, by selecting a portion of a nanoparticle, if we see a nanoparticle, you can see the whole nanoparticle, and if we select a portion of the nanoparticle, we can obtain selected area electron diffraction pattern, and this pattern shows the crystalline nature of the sample. See, this is the part of a nanoparticle, and when we scan this, or when we throw the nanoparticles or the electrons get diffracted, we get some selected area electron diffraction patterns. These are some circles, and every circle, every dots in the circle actually related to some planes of the planes that are there in the material, or rather you can say in the nanomaterial actually. We have prepared some gold, silver, and copper and platinum nanoparticles. You see, these are the beautiful structures that we have obtained from transmission electron microscopes. And you see, we have prepared silver nanotriangles also. And these are HRTM images, actually high resolution transmission electron microscopic images. These are the images. And here you see, we can see the lattice spacing, we can see different planes also. And if we more zoom in, we can see even the atomic arrangement. The different planes are there, you can see different planes are there, we can see with the high resolution transmission electron microscope. That is not possible by any other microscope actually. So there lies the beauty. And if we use this particular portion, then we can get the selected area electron diffraction pattern. Every point, every dot in the particular pattern actually gives the related to a particular plane actually. So this is every dot is a reciprocal lattice. Hope you know about the reciprocal lattice. So every dot is the viewport of the reciprocal lattice. Rather, I can say every dot is related to a planes of a particular place. So these are the SAD pattern, selected area electron diffraction pattern. If we get the pattern like this, then obviously we can get the idea that it is crystalline in structure. I don't want to talk about this. These are some AFM atomic force microscopic images. These are not in the scope actually. So this is the SID pattern of silver nanotubes, and similarly we have obtained beautiful structures in the SID pattern. As you see, we have obtained the related planes. Now the question is how we can obtain the planes actually. There are some other techniques to get the planes from the radius of this particular ring. So this is something different. We need some time to talk about this. But using some analysis, we can get the planes actually. This is the again a micrograph, 10 micrographs, and these are the planes or SID patterns related to silver nanohexagons. You see, we have obtained the planes in the HRT images. This is related to silver nanohexapod. And these planes, beautiful planes that are there in the nanoparticles, we can see with the transmission electron microscope. These are again some beautiful pictures, and these are some magnetic nanoparticles that we have prepared in our lab. And you see, I want to show you the difference. This is the transmission electron microscopic images where electron pass through, and where the electron get obstructed, there we see some dark part. So nanoparticle actually a bit bigger nanoparticles, or nanoparticles obstruct the passing electron. That's why we get some dark images. Where in the other places there is no nanoparticle, electron passes through, and there we cannot see any sort of presence of nanoparticles. But in the case of semi images, the electron don't pass through. In this particular case, electron gets scattered actually, scans the surface. That's why we see the surface topography of the nanoparticles through the same image. And these are some structures we have obtained for our prepared magnetic nanoparticles. These are some rod-shaped nanoparticles. These are some rice-shaped nanoparticles, nanoflakes we have obtained in the case of magnetic nanoparticles. Here you see another part, beautiful part of the transmission electron microscope or electron microscope is there. It gives the composition actually, and that composition we can obtain from energy dispersive X-ray diffraction, X-ray spectroscopy, what is known as EDAX spectra. You see, these are the beautiful semi-image, and selecting the portion, again we can obtain the particular EDAX spectra actually. This EDAX spectra is nothing but the characteristics X-rays actually related to that particular material. So the principle is that when some X-ray, particular X-ray of a particular wavelength knock out the inner electron from the orbit, the outer electron jumps to the inner orbit, and thereby the characteristics X-ray K alpha, K beta, and K gamma that originates actually. And every characteristics X-ray are nothing but the characteristics gives the characteristics of that particular material. So knowing those characteristics X-rays, knowing those peaks, we can get to know about the composition actually. So I have covered the part of X-ray diffraction and electron microscope. Let me go through the application of nanomaterials, some sort of. Almost in every part we get the application of nanomaterials in cosmetics, in display screen, in laptops, in cell phones, in transistor, in sensors, everywhere, in solar cell, fuel cell, medicines, everywhere we find the application of nanomaterials. Even the gold nanoparticles are useful for some diseases, and in medicine also, or in medical purpose also, we use gold different nanoparticles. In many sensor devices we use nanoparticles. So I want to just share that what the Tripura University or the Nanophysics and Nanotechnology Research Lab of my lab, our contribution to the nanotechnology research. You see, we have prepared different types of nanoparticles, and our application is basically based on sensing and removal of some toxic chemicals, especially pesticides or some fluorides. We are doing some antibacterial activity. We have applied as the nanomaterials as light emitting devices. We have applied the nanoparticles as soft magnetic materials, and there are some biological application of those nanomaterials as plant germination and growth enhancing processes. Let me share about our research work. Here we have using the silver nanoparticles, we have detected the chlorpyrifos or sensing the chlorpyrifos in water. So there are some process through which we have detected. We have used NMR spectra, we have UV visual spectra, optical properties. We have used colorimetric process in detecting the chlorpyrifos in water. Similarly, we have used glyphosate as very worst pesticides which we have sensed in water, published in Journal of Hazardous Materials. So different techniques we have done the sensing of glyphosate in water, and we have not only sensing the glyphosate, but we have removed the glyphosate totally from the water using the silver nanoparticles. And finally, in one sort of spinal fluid nanoparticles, manganese fluid nanoparticles, which is a magnetic nanoparticles, which is used as a blue LED actually. And there are some antibacterial activity of silver nanocrystals. We have used CDS or semiconductor nanoparticle CDT in the antibacterial activity also. And we have used silver nanoparticles in the case of germination of the plant, some different seeds. We have seen that it germinates faster. There is a growth, faster growth. I want to say that silver nanoparticle can be used as a fertilizer in optimum cases. And another part is that my students are working in different labs, using the different facility, national facility. One such facility is iron irradiation at IUSC. You see, this is a Pentagram generator. It is a huge generator. It is a huge accelerator. Using that accelerator, and if we irradiate the swift heavy ions on nanomaterial, we can modify the properties also. And this is the Piyush, who is now a part of the organizing committee, who has worked in different instruments out there at IUSC. And another thing is that like X-ray diffraction, we have used the neutron diffraction study also at BARC. This is not the picture that I have taken, but this is the picture that I because inside the reactor, this is the reactor actually, nuclear reactor at Bhabha Atomic Research Center. This is the picture of the reactor given in the website, because inside the reactor you cannot take the picture, you cannot take the camera or anything else. So here actually in this portion there is through this portion some neutrons come out, and we people use this neutron as a source of neutron diffraction study. So there I went there, I did the experiment, and it is very beautiful experience that I am sharing, that I have seen the nuclear reactor as well. And using the neutron diffraction, we can study the magnetic properties of the nanoparticles also. This is the picture of my lab members. They are working in silver and gold nanoparticles. They are working in semiconductor nanocrystals, also magnetic nanoparticles. They are working. One is working on swift heavy ion radiation. Also, we have started working on theoretical explanation of the phenomenon using DFT and other simulation techniques. In the conclusion part, I want to say is that we are contributing some nanotechnology research from our lab. Tripura University also is contributing in the nanotechnology research, and India is one of the leading countries in nanotechnology research actually. So at the last, I want to say that small is big. I mean that small means that nano technology, that small technology is very big, strong and energetic and beautiful as well. So thank you very much again. With this, I want to conclude my lecture.
Thank you, sir, for your beautiful presentation. The participants have come to know so many things from your presentations, and some of the participants will go for their higher study in your institutions also. They will get benefited.
Yeah, that I want to say that this is not the time to call actually. This is the pandemic situation. So when the pandemic situation will get over, many students may visit our lab or different lab, because we have here our scanning electron microscope is there, atomic force microscope is there. They can visit and they can see the lab actually. They can get some idea about the what are going on in this Tripura University.
Yeah. And I used to say actually some of the students are completing their BSc. So for their PG course, they will go Tripura University also. Okay. And
Yes,
some
yes,
of
yes,
them
yes.
are doing the research also. That is why I am telling. So, sir, so many questions have come from different participants. So all the questions I am not able to take. So few questions uh,
Yes, yes.
from Dipankar Datta. What are the main applications of quantum dots, heterostructures, lasers, and optical switching and its future prospect? So the
Please
question
tell
has
me,
come from Dipankar Datta.
please tell me the question again.
Yeah, what are the main applications of quantum dot, heterostructure, lasers, and optical switching and its future prospect?
See, regarding the first question, I want to say that quantum dots has huge application in diverse field. We can use the quantum dots in electronics. We can use the quantum dots in biological part also. So, a single nanomaterials has a different application in different fields actually, in which way nanotechnology will use it. Regarding the optical switching, this is a different part, you know. Optical switching is something very specialized things. People are working on it, and it is a very bright future, rather I can say.
Yeah, so another question from Shurovi Dhar. What are the harmful effects of nanotechnology in the human race?
See, this
Very
is
common.
again a very questionable, very debatable
Yeah, pertinent
part is
question also.
there. Yes, a very debatable part is there. See, we need to see the bright part of the nanotechnology. So nanotechnology is giving us so many options, so many useful things that we can ponder over, we can go after it. But at the same time, we need to take care of the things, because if we have a powder sample of nanoparticles, then that powder sample you may inhalate. Okay, so that may harm your lung, that may harm your overall healthy part. So you need to be very careful in handling the nanoparticles. This does not mean that we should not use the nanoparticles, because people are using nuclear material, people are using different materials with carefulness. So similarly, we need to take care of the handling of the nanomaterials actually.
Another question from Dipojyoti Bonik. How does excitation okay, let me see actually. How does excitation modify the band structure of semiconductor nanocrystals?
Actually, you see, I haven't covered this part because everything we cannot cover in a single lecture. I have given the lecture slightly taking every part of this. So what I want to say is that if we go into the nano region, then what we see, the band gap in the bulk material, that band gap increases, and there in the nano region, the splitting of that band structure takes place. What is known as a quantum size effect. Okay, in especially in the region for semiconductor, in the region of 1 to 100 nanometer, that sort of quantum size effect takes place, or band splitting is taking place. And because of band splitting, we see different sort of color in the nanomaterial if we vary the size from 1 to 10 nanometer. So in the nano region, actually we are increasing the band gap. When we go to the nano region, the band gap increases, as well as the band structure splitting is taking place.
Okay, Shubhoguru Rai from SS College, he has some query. So he used to know some how something about the preparation of nanoparticles of specific size. Tell something about how to prepare nanoparticles of specific size. Regarding the different dimensions, perhaps he has put the question.
Now, what I got to tell you that I have understood that he is telling about the uniformity in the nanoparticles in the preparation, I think. uniformity in the preparation of the nanoparticles. So far, I think.
Yeah,
So regarding
yeah.
So regarding that, I want to say that it is very difficult to control the size of the, the size distribution of the nanoparticles by chemical methods. More suitable or the size confined, size distribution can be narrowed by physical method. If we go to the lithographic technique or some ball milling technique, there we can reduce the size distribution. We can get more uniform size nanoparticles rather than chemical methods.
Okay. So thanks a lot. Actually, so many other queries are also there. So we are not able to
Yes, it
take
is
all
not
the
possible, I think.
questions because we are running short of time. So thanks a lot for enlightening us regarding the nanotechnology, different prospect of its applications, and so many things in your lab itself you are studying, and I know you very well. So thanks all. Our students will be also get benefited in the coming days. Thank you all. Thank you.
Thank you very
One.
much, Rogo. Thank you, organizers, especially Sujitda for inviting me, Sujitda and Rahul for inviting me or giving me a chance to speak in your special webinar. Actually, thank you very
Yeah,
much.
on the coming days also we'll be inviting. Okay, so we'd like to do the work in collaboration. We should share our views with the university, particularly with our there is different learned scholars and research persons. Okay, thanks.
Okay, thank
Thanks
you
a
very
lot.
much. Thank you. Thank you. Thank you.
So now our last speaker, invited speaker, is Dr. Rahul Bhattacharjee, Associate Professor, Department of Physics, Women's College, Agartala. He is talking on impact of ICT on higher education. So let me say a few words about Dr. Rahul Bhattacharjee. He is actively associated with teaching learning process. He has his PhD from Tripura University. He published many papers in national and international reputed journals, and particularly he is giving suggestions how, and particularly in this webinar also he took participation actively, and for its great success in behind the screen he has also he done also a lot. So I invite Dr. Rahul Bhattacharjee, Associate Professor, Department of Physics, Women's College. Please share your paper.
Uh, Thank you, Raghunandan Das. Basically, we two college, Women's College and Dharmanagar College, took initiative that recent scenario. What you find that COVID-19 and all the lockdown situation make us confined in our room. So let us do something. So we started to feelings. Let us do something on using this type of platforms, using this type of platform webinars now using by many faculties all over the India and abroad also. So we also give our student a chance to interact with the many peoples in our neighboring state, and the available resources are with us. So we talk to many persons how to do the webinar. Then again, organization secretary request me to give a talk. So I say I will speak. I say okay, why not, you speak also. So using this opportunity, actually, Dr. Sujit Ranjan Das, secretary, told me to request me that you speak also. So using this opportunity, I choose a topic which is very general one, and also in this pandemic case and in this lockdown case, I choose these topics. Actually, basically, I was associated with the face-to-face meeting, face-to-face education for the last 15 years. Along with this, I also associate with open and distance learning for the last 6 years. I was the coordinator of the institution, my institution of IGNU Learning Center. So using the idea of open and distance educations and the face-to-face educations, I think I will speak in this matter also. What is my PhD to be? I did not cover here. It's a very new topic for me, and for me also. Then I'm learning from the different sources, and also to deliver something like topic. This new from me. So I'm sharing my slide. Is I'm audible to you?
Yes, sir.
Okay, let me share the slides. Is slide is visible now?
Yeah, it's visible now.
Yes, thank you. So again, I want to say something like that. Uh, our two colleges, my colleagues, Dr. Sajit Ranjan Das, Dr. Raghunandan Das, Dr. Shoma Bonik, Dr. Subroto Dev, Mrs. Joya Bhumik, and my student Piyush Ranjan De. So I want to thank all my colleagues to give me a chance, opportunity to speak on this webinar. Now, as Raghunandan told you, that title of my talk is Impact of ICT on Higher Educations. Let us go one by one. Now, organization of talk is that present scenario of higher education in India, introduction to ICT, role of ICT in higher education, future learning, blended learning and MOOCs, learning management systems, highlight of national mission of education through ICT, MHRD Government of India, SWAYAM portal, and different type of MOOCs platforms available now. Now, this is the All India Survey in Higher Education, OISI. It's called OISI 2019 data. In India, there are 53,620 number of higher education institutions. That means 10 plus 2 level education institutions. Total number of students enrolled 3 crore 70 lakhs, 2 crore 60 lakhs in colleges, 70 lakhs in universities, and 20 lakh in standalone system. Standalone means they are not affiliated to UGC or AICT. Number of affiliated college is 41,901, and standalone higher education institution are 10,726. Total number of university 993. Among them 394 in rural areas. How amazing. I am also surprised the number of university in rural area 394. Total number of teachers engaged in higher education 14 lakhs. 11 lakhs in colleges, 1 lakh 58,000 in universities, and 1 lakh 47,000 in standalone systems. And gross enrollment ratio 2019 data, it shows 26.3%, female percentage 48.6%, and distance education 10.62%. Again, when we start our job in higher educations, that time 2004, it was only 7%. Gross enrollment ratio in higher education is 7%. Now 2019, we find it is 26.3%. However, it is very less compared to say Japan, USA, where it is more than 60-70%. USA, European country, where higher education gross enrollment ratio in higher education is of the order of 60-70%. So it is now it is also promising that female percentage is 48.6%, and distance education 10.62%. Now, what is ICT? This is a copybook statement. Now, ICT is made up of three words: information, communications, and technology. So, what is informations? It is a collection of facts or knowledge acquired through study, experience, or instruction from which further conclusion may be drawn. So, information means a knowledge. Now, communication, it is nothing but the disseminate the knowledge. So, it is the process of conveying information through exchange of ideas, feeling, intentions, attitude, as well as by speeches, gesture, writing, behavior, and possibly by varieties of ways, including the electromagnetic means. And technology, it is the discipline dealing with the art and science of the systems. Now, ICT mediated teaching and learning. If you see the ICT mediated teaching and learning broadly specified in four types, still it is a debatable things. So ICT mediated teaching and learning have distance learning, one very old method of learning, 1960-70 that that learning was started. They changed it time to time. Then e-learning, this is a new concept. 1991 this concept came. Blended learning, now people are talking about the blended learning, which I am interested in, and we are also engaged with these blended learning systems. And the newer one, which is the future learning system, is massive online courses or MOOCs. So basically all are coined in the same from the same platform, that is ICT platforms. Now their things are changing. Educationists are defining various thinking, but I think future of our education is based on blended learnings and MOOCs also. Now let's see what the national education policy comes out land out to 2023, and let's see what is the scenario, what is the curriculum they develop on the basis of this. In India, higher education system grown vertically in last 2 decades. It is a great challenge to meet demands of quality education for all, which is driving force for economic growth and development of a country. Induction of information and communication technology (ICT) based higher education will fulfill the demand of quality, access, and equity. This three word is very important: quality, access, and equity in higher education. This will further reduce the cost of educations. Now, advantage of ICT mediated learning. What is the advantage? Improve quality of educations, improve accessibility, reduce the cost of educations, innovative approach for teachings, overcoming geographical area, able to track learner progress. I think all if you understand this is a very common word. Quality will increase the quality of educations, improves accessibility. It goes to everybody's door. ICT can uh, ICT can send information to everybody's door corner. Reduce the cost of educations. Now, normal education face to face, a lot of cost required, primary cost is required. But in case of ICT means, if you have long bandwidth, if your bandwidth is good, then it is a cost is education is very less. Innovative approach of teachings and overcoming geographical barrier. It can reach any part of the world. You can study from there. Suppose Australia, from say suppose you would enroll any institute in America and can study from here also, able to track learner progress nowadays. A lot of learning management softwares are there, so you can adjust the learner progress also. So challenge of ICT mediated learning: need training to the teacher as well as to the students. Yes, it required teaching. Our teachers, 70 to 80% teachers are still do not know how to use the ICT, and they do not use the ICT, then only believe in the normal classroom type of teachings. So we required a lot of teachers, training to teacher, also to student also. Many students are not so ICT enabled, so we need to also the training to teacher also. Expenses as requires computer internet facilities, and it is okay. In India, we find it that a lot of marginalized peoples are not coming comes to this ICT based education, cannot acquire this ICT based education because they don't have the internet facilities, don't have the computers. And okay, today we can also use the smartphone also, can knowledge can we can use the smartphone smartphone, but still it also the not in the hand of the poor peoples of our country. And internet facilities, a lot of people are complaining that our bandwidth is very small, and we are not can accessing the education through ICT. Is a common face to rural India. So we have to increase the we have to you have to increase the accessibility. We have to hindrance. We have to remove the hindrance. Sometimes it differently to infringement to copyright also. Sometimes we find that in India also that ICT mediated education systems as copying from other sources. So this is also a very difficult or very dangerous things, is that anybody copying the documents from other sources without their knowledge. So there is an infringement. Copyright Act also are there. uh, Now, this is one of the US Department of Education 2009 findings. Classrooms with ICT learning equipments, whether completely online or blended, on average produce stronger learning outcomes and motivation than learning face to face alone. So face to face alone cannot produce the learning outcome, so we have to use the ICT technique. Now, next, second findings is that 86% of teachers worldwide agree that students are more motivated and attentive when computers and internet are used in class. ICT has strong motivational and positive effect on student learning behavior, communications, and process skills. So this is another study in 2006. They are saying that 86% teachers and students community are interested in ICT mode of educations. Now, a more meaningful definition of ICT. What does ICT means actually? An umbrella term that encompasses all communication technologies that provide access to informations. So what are that? That is, the ICT means internet, wireless network, satellite communication, cell phones, digital television, etc. So all come under the ICT. Nowadays, lot of lectures are going on local cable TV also. Students are accessing. Student mainly those who are uh, class lower class students, class school students. They are accessing the through their lectures via cable television also. So ICT cover all the terms: internet, wireless network, satellite communication, cell phones, digital television, everything's come under it. Now, definition of e-learning. So e-learning is a new type of learning. E-learning means electronic learnings, digital form of learning. Here emphasis on learning means we are giving the importance of learning, not the technology. So we are giving the importance on learning. E is just mechanism. So this is the mechanism how we send information to the learners. E-learning is a learning in a way that uses information and communication technology. So that E is clear about here is that E is nothing the mechanisms, not the subject matters. So now, before going to e-learning, we have to develop e-content. This is final things. Is that if you do not have e-content, you cannot jump into the e-learnings or ICT based of learning. So, what is the e-content? Nowadays, most of the peoples of like us who are related with education systems, they are now done a lot of emphasis on e-content development. So, e-content. What is e-content? So e-content start with static constant means suppose we are the subject expert in matter of say physics. I'm teaching suppose something units are there. So I have to develop some static constant using say word processor. So I have to write some text, some value addition, quizzes, graphics, image, etc. as to explain my subjects. Then it will go to the next technical team. Nowadays most of the teacher technologically enable also, they can do the multimedia enrichment themselves. So there is required that you have to static content, make some multimedia enrichment, do some multimedia enrichment. What are the multimedia? You add audio, add video, add animation, add simulation, etc. These are quite possible nowadays, but a teacher must be in knowledge of the use of the technology. So if you develop this static content, then multimedia enrichment, and then it can gives you the e-content. So when you develop e-content, you then go to the ICT mediated equations. Now, there is another characteristic of adult learner. Adult learner means those who say those who are at the age of 18 or above, plus above. So, if you see the characteristic of adult learner, then you can say that 10% of what they read. So, by reading, we like adult. I think all the listener are adult only. So 10% when you read, we learn only 10%. When we hear, then we can learn 20%. When we see, when we viewing, learning process is under viewing process, then we learn 50%, 30%, sorry. And when we see and hear, then we learn 50%. And 70% what we say, if we say, then we say learn 70%. And when we do something, then we can say our learning 90% learning is over. So we have to consider this type of learning scenario also when developing e-content on going to for any course. Now, this is very popular term today's world. After pandemic declares, pandemic and the COVID-19, this time is everybody in higher education is talking about the MOOCs, and UGC also recent circular talking about the MOOCs. Every day they come out with a circular and MOOCs. Nowadays, 2000 courses are there. 2000 courses are there developed through MOOCs, and every day every institution comes out with the MOOCs. So MOOCs is also from a e-learning, but in a structured way. It is very research is going on very much. Research is going on to make it more reliable to the learners also. So the MOOCs is also a form of e-learning, but in a very structured way. The word MOOCs was coined by Dave Kramer in 2008. So this is a 2008 this words came, but this is now a very popular word, very popular words. So what is MOOCs? MOOCs means a massive. What is the massive? It has unlimited. A learner we can enroll a massive MOOCs can accommodate unlimited learners. 1,000, 10,000, 50,000 learner can be accommodated in a single platforms. So MOOCs is a first word is massives, and that is open, no qualification except for grades. So when you appear exam, then you require some grade qualification. Other than this, you can join MOOCs without any informal qualifications. And then online, only through waves. The process of learning is only through waves. No print material, no hard copy is there. Only online description is there. Be there, make video lecture there. You learn from the video. You appear for the exams and the courses. So courses means they sometimes make a structure of courses like 40, 15-week courses. Mainly the Indian platforms, Indian MOOCs platforms are giving their 15 weeks, 40-hour discussion, of which 20 hours in video lectures and 20 hours in others. You have to face the exams in others. So courses that designs is like there's 15-week courses and 40 hours durations. 40 hours duration means 20 hours video lectures and 20 hours for other exams. They organized exam. You have to face the exams and then get the certificates. So this is the MOOCs. Next, basic philosophy of MOOCs. What are the philosophy of MOOCs? Why it is so important today? Why UGC is talking about the MOOCs and MOOCs? Highly economical. First word is highly. One e-content developed, one platform is developed is over. Your running cost, your cost for running is very small, very less. So what you require? A laptop, a smartphone, or a tablet. So what is the 4 A's of MOOCs? Anytimes you can listen the lectures, anytimes you can listen their lectures. So anywhere, by going, say, by bus, traveling through a place, you can you can hear the lectures, you can prepare the lectures. Anyone, as I told you, anyone means does not require any formal education, so anyone can participate this any number of times. You can listen it daily at 5 hours, 1 hour, or not, any number of times you can, or repeatedly you can see the video lectures to understand the subjects. So any number of times. Some people are called it is a mini smart colleges. One can decide one's own pace of learning, so you can decide your learning times as you require. Why MOOCs? Is a very question is that why MOOCs? Is a high quality, authenticity, and interactivity. So when MOOCs platforms are developed, the content, the course content is very course content. They selected very efficient persons, very renowned persons are there. They develop this course content. So authenticity, high authenticity is there, high quality is there. So maintain the high quality and interactivity, because there is many board are there all over the India, all over the world. So they interact with each other before going to develop a MOOCs course. Coordination between academic and technical teams. If you go to the UGC website, you find that lot of coordinating institute are there in India, and I will talk also world also. So coordinating institute are there. They are giving the technical support. They are giving the academic assurance to the MOOCs. So this is a very coordinated way people are now talking about development in a time bound manner. So is also important, time bound manner. When you develop a course, develop a curriculum that have longevity also. Suppose you develop a lectures on, say, suppose lectures in, say, photography, say example photography, it have some time bound manner. If you do not deliver this course in this times, there is new things will come. Suppose you think about the engineering subjects. Engineering subject, most of the engineering subjects in Indian university, say Indian university, they are covering, say, first generation engines. Now we are in fourth generation engines. So in MOOCs, when they develop MOOCs, they consider this type of things. What are the recent knowledges? So development in a time bound manner. So they develop in a course such a way that fulfill the present scenario. And multilingual conversions, as you know, that to national education policies, a lot of regional language are giving the importance. So MOOCs are developed like that, so that every Indian languages are cover in these courses. So you will find lot of MOOCs are developed local languages also. Now there are two terms. There is two terms: equality and equity. Our syllabus, our normal syllabus are based on equality. All peoples are getting, all the students have the same syllabus. All people have the same syllabus. Some students cover the syllabus very easily. Some student, yes, okay, it's okay for him. But some students cannot cover the syllabus. Normal syllabus is like that. So some student, but syllabus you cannot change. We cannot face to face, a teacher cannot change the syllabus. Syllabus is made by university, so we cannot hand in the syllabus. But when you say the MOOCs or in e-learning, we can, there is a word is equity. So as I told you, access, equity is a one of the major terms in MOOCs development. So equity means those learner cannot get it easily, give him support, and those need support, don't give him or her support. So give support as requires as learners. So this is the word nowadays equity comes. Now there is, without learning management systems, you cannot give the ICT mediated teaching learnings, or you cannot provide MOOCs without LMS. So what teachers know cannot be disseminated to the concerned student without LMS. In COVID-19 scenario, LMS performing a vital role in teaching and learning process. There are various level of individual and institution level LMS. These are model. This is a very popular model. My eClass, Camellia, Genomio, Canva, and Google Classroom. As basically we are using Google Classroom. Most of the school colleges are using Google Classroom. Only required is everybody has Gmails or G Suite. So everybody come under G Suite. So Google Classroom basically gives a LMS, which is very popular in India because it is free. Only required that you have to need a Gmail accounts, and then Microsoft also develops a LMS, which is LMS 365, etc. So these platforms are mainly used by institutions, and we also personalized that there. So Moodle has many versatile things. One can check this Moodle also. Then advantage and disadvantage of LMS, learning management system. Advantage: support content in various format: text, video, audio. You can LMS through, you can deliver text, deliver video to audio to your students, and one can access material anytime from anywhere, everywhere. So this is also one of the motto of LMS. The evaluation of students is easier and fair based on student attendance and online quizzes. Nowadays LMS support the student attendance, how to take assignment. There is every learning software they are developing day by day. So one can easily, is a very user friendly also. You can take quizzes, but you have to know the technology, some sorts of software, how to run Google Forms and others. You have to know these things. And student and teachers can reuse the material every time they need. So one if it is available in Google Classrooms, students can repeatedly see the text, the video, and then he can get the gaps what he required. Next, so there is every advantage and disadvantage also there. Implementation of LMS requires well-built technology infrastructures. Yes, we need infrastructure, technology infrastructure. Teachers have to be willing to adapt their curricula from face-to-face lecture to online lectures. This is the teacher willingness is required. Our teachers, most of the teachers are static type of things, so they do not. They should be dynamic. Should become dynamics natures. Same style of learning every time. So it may be bored sometime on, but you can change also that you can change the learning way of learning. Okay, so I think slide is very invisible to you also. So let's comparative study of different LMS and video conferencing tool. There are various LMSs there. They are supporting various type of learning systems also, and video conferencing like Zoom, MS Teams, Cisco WebEx. Today we are with the SteamWord and Google Meet also there. There is Skype also there. That we are using Skype very well, and then using Google Meet also. So there are various video conferencing free are there. There is also which is premier versions are also there. Let us come back to another things. Look back to our old education system, Vedic educational systems. Education systems, or we call it's Gurukul. Gurukul is based on the Guru. Based on the Guru is the main prime members of the ashram, and disciplines, or the shishya is there. So what the guru know is dissimilate to his disciplines. So there is a this is the type of learning systems available in India, like Rig Veda, Vedas times. Now let us then after the British when came British converted to modern education system. So in British we find a modern education system where everyone, so there's a social revolution also there. Everybody comes under the education system. In Gurukul type of education, all are not allowed to education system. Only selective persons are there. Those who are those are social strata. So this is a debatable things are there. So this type of Gurukul systems, but during British period we find the modern education system start, and the modern education start with the chalk duster systems. So now chalk dusters have systems. What are the characteristics of chalk dusters? This is teacher centric approach. What teachers a student there. Teacher, what the teacher wants, he can give you. On student has no choice. Monologue method. Every time teacher, what the teacher is talking, student must take it. This is a monologue. Something teacher do not like it. Student do not like it, but he cannot come out the systems. Many complex concept cannot be explained. It is well known that many complex you cannot discuss a chalkboard with all the complex system. Presume that also all the learners have the same sorts of learning. So all the learners are same understanding. So it is not possible. In a class we find that some are good students, some have mediocre students, some have poor students. So we cannot cover chalk duster method, cannot cover all the things as equity, as I told you, equality and equity. Sufficient number of problem cannot be taken in classes. Slow and time consuming is okay. So this is the chalk duster systems of education systems. Now this is the future learning. What I want to say everyone, this is the future learning. What is the future learning? One is called blended learnings and another is called flip models. Flip model, what is the flip model? Let us discuss about the blended learning first. In blended learning systems, there is now much of the syllabus is covered through online, and some of the part is will be considered in classrooms. So both classrooms and online, both are dedicated to the learners. So this is called a blended learning. What is a flip model? This is a future model. I again say this is a future learning model. So what is a flip model? Normal classrooms is like that. Lectures, students are appearing the lectures, and then they go to home and do the homework activities. So this is a normal type of education system existing in our society. Now what is the flip model? What is the flip model? Flip model say you will lectures attend through online. You will attend lectures through online, and you go to classrooms for the activities, for what you learn or what you learn lectures. You go and go for activities only. So this is the flip model. So flip models, nowadays it is very popular in case of private education system also. So lectures you will listen from whom you alone, you are sitting in a computer, you attend the lecture, video lectures, and after attending the lecture, after acquiring the knowledge, you apply it into the go to the classrooms. Next slide is that Bloom's taxonomy. This is called education pyramid. Every educationist know these pyramids. This is just science people know E equal to mc square, F equal to ma. Bloom's taxonomy like that. It is a educational pyramid. Education structure based on this level, based on this concept. So there is level 1, level 2. Level 1 is remembering. You have to remember. The first method of education is you have to remembering, then understanding. You have to understand the what you remember, and then applying. Go to apply this knowledge, analyze, and then you apply, analyze your knowledge, evaluating, and then creating is like such a type of research. Means research is the top of the education system, so it is the highest peak point of the pyramids. Creating, so produce something new. So this is that Bloom's taxonomy. It's a very popular. You can search in the internet, you find the Bloom's taxonomies are there, so explained beautifully. So now future teaching model. So if we use the Bloom taxonomy future teaching model, what is that? Traditional model, existing model is that in class you will do the two things. Traditional model, remembering, understanding. When attending classes, your teachers is giving lectures, you understand this, and outside class you solve this equation, solve the everything, analyze it, evaluate it, doing the some examples, and then create something. So this is out of classroom activities. Now in flip model, what is we call the flip model? In class you will do the above activities, and what you will do outside the class in your home, you will do remember, understanding process you complete in class, and in outside in your home, it is home activities. So you in whom you will remembering and understanding level in whom. So in applying, analyzing, evaluating, creating, you are in doing in institution and in class. Now there is a famous educationist David Warlicks. We need technology in every classrooms and in every students and teachers' hands, because it is the pen and paper our time, and it is the lens through which we experience much of our world. Next, to be teachers educators. This is also a copybook statement. Uh, to be a teachers educators, you have full command over the subject. Okay, so without subject knowledge, without knowledge of the subject, you cannot go to the teaching education or teaching professions. You need the subject knowledge first. Should have done a lot of thinking. You have to be think about the subject, about all the matters before going to class. Think all possible question which can arise in a student's mind. So mainly teaching it based on vision, imagination, creativity, innovation. So these are the few points of teaching learning systems. Now, there is a very questions everybody's mind. Will technology replace teachers? If we talk ICT, if we talk e-learning, if we call blended learning, can technology replaces teachers? Is everybody question? Everybody's in mind. Technology will not replace teachers, but teacher who use technology will probably replace teacher who do not. So you have all the teacher have to know how to use the technologies. This is the fact. So teacher will not be replaced. Now it is our common scenario. It doesn't matter how many resources you have. See, the man has so many resources, leader, but he cannot. He don't know how to use the leaders. He is again. He find difficult to find what is see to the other side of the wall. He is facing difficulties to see other side of the world because he don't know how to use his his resources. So we have to be use our own resources. We have to know how we can use the resources to see the other side of all. So we have to be we have to be careful about our resources. Now let us come to another way. Let us talk about some again comes to our education system, national mission on education through information and communication technology, NME ICT, MHRD, government of India. In the year 2008-9, National Mission on Education through Information and Communication Technology, NME ICT, has been established. The main aim of this mission is to use the ICT tool to disseminate the knowledge resources to every learner as per his convenience and just in time. The objective of missions are the well-built portal, utilization of existing resources, team building and institutional support, community participations to prepare human resource database, provision of ebooks, e-journals, financial assistance, content generation from 9 to PG level. This is very important. Nowadays, UGC and not UGC only, others, Government of India, NCERT, and the other regulatory body are developing from class 9 to PG level courses. 9 to PG level courses. School students are not covered up because school students cannot be provided through e-learning mode. It is only a teacher-centric mode. So up to class 8, there will be a teacher-centric mode, teacher-centric learning, classroom type of teaching. But class 9 to PG level, there is a development of MOOCs, development of e-content, development of other form of ICT based educations are considered. Now there are various, as I told you, various institutions are related to develop the develop the ICT based education. So first is the Shashak. So this is a basically portal. This are actually provide the connection, provide the high speed internet connection to all the education institution. Our colleges, means our colleges in Tripura also connected with this ICT connection are there. So to provide unlimited access to existing educational institute through MPLS VPN connections, multi-protocols level switching, virtual private network are there. So SWAM portal are based on three basic principles: access, equity, and quality. Nowadays about 10 to 15 lakhs peoples are provided with SWAM certificate through SWAM portal, and no more than 2000 courses are developed through SWAM portals. I will talk later. Now Swayamprabha is there. Swayamprabha is there are 32 DTH channels are there. It is also available in YouTube. So class 20 is for chemistry student. This is basically class 12 standard teachings are there. 10 20 for chemistry, 21 dedicated for mathematics, and 22 for physics. So these are available in YouTube also. Swayamprabha. Now National Digital Library is there, e-Acharya is there, EPG Pathshala is there. Those who are doing PG, they know what is the EPG Pathshala, and those who are doing the graduation course, they know what is the e-Acharya, and digital library are there. So IGNU is also providing, where we are associated with this. I am associated with this. IGNU courses are there. So virtual labs, these are also the labs, because lab items, you are science, as we are related with science educations. So there is a question of ICT mode. How can you do the experiment? How can do experiment? Okay, you can you can take flavor of the experiment of virtual labs. So there's a developing by IIT Bombay, and other IIT also. 6 to 7 institute are nowadays they are making the virtual labs in reality. So you can do experiments virtually, simulation techniques in the software mode also. Now Shudganga is digital repository of thesis and dissertations submitted to Indian University. It is maintained by UGC Influent. These are available through all Indian library. We have also UGC Influent, so we are accessing Shudganga, all the thesis and dissertations submitted to the universities. Next is the Swayam. Now Swayam is a portal where it gives gives hosted, all the smokes are hosted from Swayam portal, and the associate coordinators are AICT, All India Council of Technical Education, NPTEL, National Program on Technology Enhanced Learning, UGC, CEC, NCERT, NIOS, IGNU, IIT, Indian Institute of Management, Bangalore, NIT, TTR, National Institute of Teachers Training and Research. They are all related to the SWAM portal. They are providing the high quality education through SWAM portals. Now there is another website is available, OER, where actually basically when you write the e-content, there is a question of copyright act, plagiarisms are there. So to remove or to so that this is the copyright infringement will not come arise. So any article you can choose from this website. So open educational resources, they have lot of resources. You can copy them and then develop your e-content. There you will not get the copyright tax violation of under the violation of copyright acts. So they are worldwide. They are providing worldwide the open resources. So this is their websites: explore, create, and collaborate. There is also open textbook network are also there. There is website is given there. So yeah, I just front page, I take the front page of this website. There is a lot of textbooks are available. You can quote when you are developing e-content, you can quote their name, quote any topics from there. They are absolutely free. It will not come under plagiarisms. And let us come to a student centric discussion. Let us discuss some MOOCs platforms worldwide. Now edx is a very famous platform. 2500 online courses are there giving, and there are MIT, Harvard, Boston's, all the renowned universities are renowned university are giving through MOOCs platforms. So MOOCs are there. And then next is uh, as I next is Coursera. Coursera is an again is a MOOCs platform. You can, it's a free, you can join it free. Only certificate you require to give some money, but it is a you you can afford, your student can afford the certificate price. So you can suppose you are studying at Indian university or any university like Tripura University, Asha University, you can do a course from there. So it gives you value in your what is called biodata. So it will gives you handy to your biodata if you do a course from say Linus, Duke, or Google, IBM, Imperial College, Penn, like university. So if you do the courses from them, then it gives you a very solid biodata to your education education level. Now another is Canva, is also a open source learning management systems where many institutes are there. Best educator never stop learning. So many, it's also free. You can enroll this website also. Then it's come Future Learner. Future Learn, this is an open university, United Kingdom, based on United Kingdom based open university. These are British councils are related. King's College London's are there. John Hopkins are there. So there are many renowned universities are joined to this type of Future Learn MOOCs platforms are there. Learn new skills online with top educators. This is their banner. This is their logo. So learn 100% online and world-class university and industry expert. Develop your career. Learn a new skill. Join for free. You can be free join to those courses. And then Udemy, this is a commercial, basically commercial. They are Indian prices. They are providing various courses through Indian prices also. So Indian prices are available. So there, this is San Francisco based open learning institutions are there. You can enroll. The Investia. So a German company, actually basically Spinger related to this Spinger, and Iversity, basically Iversity German company, and Spinger Nature is there. So you can find this MOOCs also. Then uh, Open to Study. Open to Study is an Australian MOOCs platforms. This is also an open to study short courses are not there. You can undergraduate or postgraduate level. You have to enroll under postgraduate or postgraduate courses there. You can do it. Then Open Edu, this is a European Union MOOCs platform. So you can find there are various type of courses. There are courses, framework, science, arts, any subject. This is not a that you are physics, you have to enroll physics. You can choose choose in say in telecommunication also. There are you can marketing also. You can choose any type of courses there also. Then it is Udacity is a commercial side. Udacity, you can commercial, you can go to the and see the various type of courses they are offering. Then last one is P2PU. There is a network. The vision of this creating and sustaining learning communicate in public space around the world. They bring people together to learn from each other. They train facilitators to organize their own network, and they develop curate open education resources. They build open sources software tools and support flourishing learning communities. So they are basically supporting to the learners, to the librarian, to the educators, to all the stakeholder. They are giving support. So there are 856 learning circles are there. India also they have 30 centers are there. So 600 courses are there. 196 participating cities are there. So a P24 is there. So these are the 10. I talk about 10 massive online courses platforms. There are many platforms are there, and because of COVID-19, many institutions come forward so that learning cannot be stopped. Let us see, a bird sitting on a tree is never afraid of branch breaking, because her trust is not in the branch but on own wings. Always believe in yourself. This is the philosophy of life. Always believe in yourself. To success, we must first believe that we can. So this is the Michael Korda, one of the renowned educationalist is there. So there I am finishing my talk. The reference, and thank you.
Thank you, sir. Thanks a lot for your very informative presentation. So now I request Dr. Sujit Ranjan Das. Oh, anyway, so it's now for interactive sessions. So many questions and there is queries are there. So out of that, I am putting some. Yeah, this one. So, sir, one question has come from Ayonava Varcharji. How to compensate for the lack of body language that is usually present in a student teacher interaction and helps both parties subconsciously to communicate better and more effectively. The question has come from Oyanavo Bhattacharya. Question I am repeating once again. Yeah, please, sir, you unmute
Oh
first.
yes.
Please, sir. Yeah.
Okay, I
So
see the
please
question.
listen.
Okay,
Yeah, you have the
this is a
question.
yes. Okay. Last few actually basic few month actually basically few month people are giving lectures through online mode. Face to face mode is a basically teacher centric modes. Okay. Now if you go to a e-learning or e-learning based of or ICT based of educations, lot of things are there. Technology. See, today lectures many lectures are not audible because of technology. So in between us there is a technology also there, and one of the experts what his opinion is that you have command in language first. So before going to any body language or anything else, you have to be command in language, and the command in subject. Without subject, and nobody can give lectures. It is not my opinion. It is the expert opinion. Is that without your subject knowledge, you cannot jump into the education system. What about the body language? What about the your intention? If you have not clear about your subject, you cannot go for teaching. So first of all, you first of all clear about the subjects and your command in language. Second option is that you have to command in language. It will not comes in a day. You have to develop it. You have to develop. You go through various type of experiment through yourselves. I we also doing the same experiment, and the since I'm using microphone type, this is a dynamic microphones are there, so you have to be used this type of technology also there, that no noise should comes. So you have to be some sorts of technology to enable things also there. So you have to be learn how to use the most of the modern technologies, how to use them, how to develop this. So body language, yes, okay, is talking about the body language. Yes, influence of teachers. If you suppose if you are a good teacher, you can influence through online also. A teachers in an online, I'm talking about some Bakshi, forgot the full names. I'm looking his lecture on this yesterday only, and his giving intention is clear that you have to be enough command on subject, enough command on your language. Okay.
So another questions we are taking from Alokesh Das. Is it visible, sir?
Yes, yes. Do you think virtually learning emphasizing the social abnormality among the learners? Yes, learners basically what happens that every learners is when we start we also start online classes just few months back. We have experience of online teaching just 2 months back, 3 months back. We started the online classes. So the situation of learners who are suppose sitting in a remote area not accessing any internet facilities. And I forgot to mention you that India has average in internet speed is 7 mbps, whereas other country like Japan, USA, that they have using 25 mbps connection. They have net net access of 25 mbps, whereas we have only 7 mbps. So how the situation of the learners? Yes, we need a better infrastructure, we need a better bandwidth, we need a technology, more and more technology enables in our society, so that a poor to poor learner can access this technology. Yes, we are forced to do so nowadays, we are forced to do so. But I think it is my view, and also the other expert view, is that we may be under the influence of such a type of things, such a type of unlock, or such a type of such a type of quarantine conditions in future also. So we should not stop learning facilities, we have to develop the other platform also.
Okay, another questions we are taking.
Yes, Rimi Dotto Chaudhary. how
Saying
we
all
can go how we can go different approaches by different individual make the learners know the learning effectively and better understanding. And data analysis is in the easy ways, that easy diagrams too. Actually basically e-learning methods is one other, is that how you people are using a lot of animation, lot of diagram to give the learners suitable for every learner, that he can learn well. So it is actually we teachers community not aware of this type of e-content development or multimedia type of using of multimedia. So I think we teachers community, as I one slide I show that the teacher who don't know technology, they will be one day go off. So you teacher, those who, I think most of the today the participant may comes into the teaching profession. See, teaching profession, if you want to comes to teaching profession, you have to know the way of subject and also the technology well. See, to make the learner more and more learner centric, you have to develop something like develop say gif file, how to create gif file, how to create the animations, so how to use the PowerPoint easily. I also not learn many not know very much. Young generation, Piyush may know more than me. I just use others viewing others to develop my slides. It's difficult to create such a type of highly attractive e-content. So you can add, everybody should try to add something like gif files using live animations in their slides. So we are basically a teachers, we are basically a classroom type of teaching. We are habituated with the classroom type of teaching, but we are forced. I am again saying, forced to give lecture in using ICT tools also. So I choose the topics without my choosing my research topic, is that because we are facing lots of troubles. So we are facing troubles, let us discuss with you. Let us discuss, as told you, the learning pyramid. If you see the learning pyramid, discuss. So I discuss with you because this is I am facing the problems. So what I today I did talk, it is because I am facing the problems, and I share it with you. I do not consider physics topics, because physics topics sometimes bore you. My research topic will be really bore everyone. Everyone. So I avoid the research topics. If I show you equation after equation, all of you bore and leave this lectures. So I choose a topic which is I am facing troubles. and you also face troubles. So let us go together hand in hand, and let to go to better society. And I again told my students that go for MOOCs. See, don't afraid of that I should enroll, why I should enroll Australia. Don't afraid of this. Go and trial and error method. To do try. Go to SWAM portal, enroll yourself. I find many students are hesitating. Why you are hesitated? I enroll in SWAM. You also enroll. You also enroll. I am enrolled in e-content development many courses, and I think Sujit also smiling, Raghu also smiling, and that we also don't know the how to develop the e-content. So every teacher we don't know what is the, how to develop the e-content, but we are learning stage. So we are finding who can teach us. We can teach us. So there is a lot of education needs to come forward to give the idea how to develop the e-contents, but subject content must be ready, otherwise you cannot go for jump into the educations.
Thank you. Thanks a
Thank you.
lot.
Thank you.
Actually, all we are the learner, and
Yes, yes.
it's very pertinent that a good absorber is a good radiator. So first of
Yes.
all of we must absorb much and much, then we can
Yes.
radiate properly. But
Yes.
absorption should be in a particular way, and its
Mm.
radiation should be also particular way, so that the deliberations will be effective and the learner will get more and more interest. So I think all
Beneficial.
the
Yes.
participants have got enough interest from all the four invited talks, and they are get benefited in many ways. So now I request Dr. Sujit Ranjan Das, head Department of Physics, Government Degree College, Dharmanagar, and organizing secretary of this particular webinar, for offering vote of thanks and share with words this particular webinar. Dr. Sujit Ranjan Das, sir, please.
Thank you. I believe and hope that I hope and believe that we have received many informative informations actually from different invited speakers and learned many things from them. And on the behalf of the organizing committee, acknowledgements are due first and foremost to both the college authorities for their support and thoughtful throughout the programs. As an organizing secretary, I am thankful to all the members of the organizing committee for their insightful and constructive interactions. I sincerely wish to record my thanks to all the invited speakers for sparing their valuable time. Their lectures actually have energized us a lot. And I am pleased to thank all my colleagues, especially Piyush De, technical coordinator of this webinar, Dr. Ankon, Shina, and Sri Abhijit Dash for their cordial cooperations and helping attitude through the programs. Although, thanks due to the coordinator IGNO Dharmanagar for providing the internet facilities for the today's programs. Last but not the least, my appreciations to those who faithfully attended the whole sessions and make it a grand success. And one important note actually for the participants, especially feedback form will be available in YouTube now for 1 hour only. Please fill it correctly and send. Thank you all.
So this is the end of the program. Today's program is concluded over here. So special thanks goes to the participants who have participated actively interacted frequently, put so many questions, put so many queries, enrich the program also. So hope taking those inspirations we'll be able to organize more and more webinar in the days coming. Thanks all of you. Thank you.
লাইভ স্ট্রিমিং স্টপ করে দাও পীযূষ, স্টপ দ্য লাইভ স্ট্রিমিং।
Rahul da, thank you.